Okay, so guys, we all started with understanding with basic AWS architecture and foundation. So basically, what we are following here, this is AWS Certified Solutions Architect Associate training. It's a foundation level training, but for the sake of overall understanding, I try to elaborate as much as possible wherever it is required so that we get more exposure to the real environment. So we started with on day one, we started with understanding of general cloud understanding. So we all know that there are three different types of cloud architecture. There is uh, IaaS, then PaaS, and PaaS and SaaS. So overall, we need to know about these. Overall, we need to about Okay. So overall, we need to know about these three different cloud models. What are these cloud models and why do we need to know about these? Actually, in every interview, you will have at least one question around this concept. What is IaaS? What is PaaS? And what is SaaS? And sometimes they would say, what is an implementation? What is an example of IaaS in AWS cloud? What is an example of PaaS in AWS cloud? So in general, for general remembering, always remember that mostly cloud providers offer two of these services. They offer IaaS and PaaS. Most of the services are IaaS and PaaS. Okay, just a second here. Okay, so I was just fixing my uh, whiteboard thingy. Okay, so IaaS and PaaS, most of the cloud services are IaaS and PaaS. So and SaaS is basically provided by cloud services, cloud providers, mostly on large software basis. Large software basis meaning. So one of the example of SaaS is Office 365. So Office 365. So Office 365 is SaaS example. There are some other tools that you can remember, but IaaS and PaaS, a clear boundary. We need to remember that clear boundary between IaaS and PaaS is that anything related to EC2 is IaaS, and so whenever you're directly working on EC2 instances, whenever you're directly working on virtual machines, whenever you have to install a virtual machine, launch a virtual machine, working with a virtual machine, that is all IaaS. And whenever you're working directly with a service, that is so one of the services is considered as S3. S3 is that service. Lambda is another service. We still have to learn Lambda. And then there are SQS, SNS, and services like these where you directly don't work on EC2 instance, that is considered as PaaS. So IaaS, infrastructure as a service, platform as a service, and SaaS as software as a service. So another big difference between IaaS and PaaS is that here you're working with here you're working directly with the virtual machine. So for example, a website can be hosted as PaaS. A website can be hosted as IaaS, and a same website can be hosted as PaaS solution. So if it is, if you directly need to, if you're directly hosting it on EC2 instance, so here I mean, so when you create a EC2 instance and then you install the web services on this, so web services will be, it will be Apache, Apache server, or it can be IaaS. So first of all, you install the instance, then you install these web services, then this, and then you host a website. So then you will host a website in this. This is known as IaaS. So this is how clear we need to have that understanding that you created a EC2 instance, then you install it, then you install the web services, and then you install the website, then you deploy the website, then that is known as that you it is an IaaS implementation. But if you go to, but if you use not the EC2 instance, so so simplest example is that you will host a website inside S3. So inside S3, you will go and you will host a website in this. Then this is known as PaaS type of implementation. There are some other services involved, but here the point I wanted to make is that here you're not working directly with VM, but you're still accessing the website. Now that simply means is that there is a VM in the background. There is always a VM in the background, even in the even behind the PaaS services. So behind EC2 instance, there is a VM that is hosting that website, but you're not directly working on the VM. So that is what is the big difference between when you implement real services. Here you have to log into EC2 instance. Here you will be responsible for operating system and everything, but in PaaS you don't know, you don't worry about the EC2 instance, you just worry about the website. So this is one understanding that we need to have. uh, Other than that, from this basic lecture, so there was IaaS, PaaS, and SaaS, and then yes, there is private, there is cloud models, different cloud models, which is private, public, and hybrid. Private, public, and hardware hybrid. So these are, I think, most of you already know about these. And so on day two, we started working with IAM. We created our first IAM account, and creating that account, whenever you create an account in AWS, so we need to remember the hierarchy in AWS environment. So in AWS environment, what happens is that we have something called a region when you create a new account, and then inside the region we have availability zones, and inside availability zones, we can have multiple data centers. You can have in a smallest availability zone, you can have at least two data centers. So in smallest, there can be at least two data center, or there can be 4 and 5 data centers as well. Then in each data center, you have servers and you have all these different AWS applications. So in each data center, you have EC2 service, you have S3 service, you have database services, and then so this is what this so and this is where you start with a root account. So root account is the one that is responsible, that can do everything everywhere. So for that reason, you will keep that root account safe, and then you start creating your own IAM accounts. So IAM account, first account will be made by the root, and then second account you can make it admin, and under that you can create all these different type of accounts in this. So tomorrow we'll be learning about security and Active Directory and everything. So but from here we need to understand, we need to have that in mind whenever you go for interviews, whenever you're discussing with someone, you need to keep that architecture in mind, that this is the complete architecture and this is how you will start deploying your AWS services. Then on day three, we talked about regions, availability zones. We have EC2 Windows instance, then we have Linux instance, and And then we started talking about storage accounts. So S3 is the storage account, and we all know that storage account is just a disk. So it can be internal to a laptop, it can be external. So internal disk is known as EBS, and external disk is known as S3. So this is S3, and then we started talking about security. You can provide security to these storage as well. Glacier is archival storage, and EBS is a block level storage, object level storage. We went into that detail as well. Cross region replication is that if you want to store the same disk in another region, so we know that you can complete that replication. You can create a replicated disk and it will start replicating to the other region. Lifecycle management, it moves data from all of the different pricing tiers and speed to all of the five different available S3 plans. So five different available. Number one is standard plan. Secondly is IA plan, and third multi-zone IA plan. Third is one zone IA plan. And there is intelligent tiering. Yes, there is one that is introduced recently that is known as intelligent tiering. And so one standard intelligent tiering, multi-zone IA, one zone IA, then we have Glacier, and then we have Glacier Deep Archive. So these are the five different plans, and lifecycle management based on our requirement. The disk will be the files and the folders can be moved from standard to different type of archive. So here you can save on the cost of the storage, and also you will get a better speed. If you move if that data is frequently used and you need better speed, so you can move between these different type of storage plans. Now, is this something new that we know, guys? Being in the computer field, we all know about the different type of disk. Even in real environment, we know that HDD is the older technology, and then STD is a newer technology, and within STD is a newer technology. Other than that, in real environment there is something called SAN as well, then there is something called SAS as well. So there are always these different type of storage available. And when we were going through this, I also shared with you an example that in the real life, we also use different type of storage. We have a drawing room for different type of storage, we have a bedroom, we have a storage, we have kitchen for different types. So this is exactly what these different storage services are. Then we have bucket static website, so you can directly upload a website within S3. Then we started understanding database services. So within database services, if this is the first time you're hearing the database service is nothing but an Excel sheet where you can store information. So in Excel sheet, you have a worksheet. So when you create an Excel sheet, you create a worksheet, and then within the worksheet you have rows and columns where you store all this information. And so a worksheet is used for mostly used for, I mean, worksheet. Yes, Excel is used for many complex storing some complex reports and making some reports. But Excel sheet is not enough for large applications like banking applications, or maybe even the patient record in the hospital, and airline records on the airports and all that. So for that, we have databases to store information and to automatically run reports on that information. So when it comes to databases in AWS, there are these five type of services available. Number one is RDC, which is relational database system. Relational database system is the most common one that is used in all organization. Wherever you go, relational database server, you will find a relational database system. Now, a relational database system, in this type of system, you will store structured data. So structured data will be stored in RDS, relational database system, and whereas the other type of database is called DynamoDB. DynamoDB is basically for unstructured data. So this will be unstructured data that will include where you can store all types of data within DynamoDB, and this is also known as SQL type of data. And this is known as non-SQL type of data, non-SQL type of data. Within RDS, there are different type of examples available. There are different types of RDS companies are offering. So for example, Microsoft offers SQL service. Then Oracle is Oracle. Oracle is also a RDS. Then there is MySQL is is another type of database than MariaDB, and then there is another type of DB as well. But the most common that you will find in many organizations would be SQL and Oracle. So this is one of these you will be working on, and so in databases you will be working with DBAs, or you will be working with the application architect. So application architects are basically those people who directly work on application with databases. So we are considered as, so we once we finish this, we are considered as mostly, so we I mean our so we are considered as platform architect. So in many places, the architect levels are different. So we are considered as platform architect. Then platform architect works with the platform architect and also enterprise architect. So enterprise architect, but here Microsoft calls this platform architect. AWS calls us solution architect. So the definition of architect is different in different places, but we can be a platform architect, solutions architect. Enterprise architect is a person considered who is basically who understand all types of architects. So enterprise architect is the top architect that understand application architecture, cloud architecture, physical data center architecture. So most of the time these databases will be managed and owned by application architects, and they will be working with DBAs and programmers and developers to basically manage their application. So RDS is relational database system, structured data, SQL databases, whereas DynamoDB unstructured data and non-SQL databases. Aurora is basically same as RDS. Aurora is same as RDS, but Aurora, and there is no difference between Aurora and RDS. Aurora is a proprietary RDS database from AWS. So this is so no difference between these. When companies deploy databases, they will be also offered Aurora DB. Aurora DB would give them RDS, but then Aurora DB is a complete database system that the company has to adopt and move into. So if they are using SQL, they need to move their complete application to Aurora, or they need to move from here. So this is complete database solution from AWS.
So
Redshift.
why they call it like serverless?
Yes, so Aurora is basically comes in both type of solutions. So it comes as PaaS solution, which is serverless, and it is also a server based, just like its SQL comes in two different version. So you can install it in an EC2 instance as a SQL database, and you can also have this as a service where you can just which is it's a PaaS solution for database. So Aurora comes in both flavors: Aurora DB, normal DB, and serverless as well. So IaaS and PaaS solution.
Thank you.
You're welcome. Then Redshift is basically a data factory. So this is just a data factory, which is basically a warehouse service And warehouse services, basically where you will bring huge databases, huge sets of data, and the data will be analyzed and then converted into meaningful reports. So this is Redshift is used as a warehouse of databases, and here the elastic cache, we know that it's the temporary memory that is in between the database and the application. So the database and application. So this is your application, and in between this is Elastic Cache. Elastic Cache would keep the most frequently used data within Elastic Cache, and then so the main idea is to make the application faster response, and also to load balance the activities within the database. Guys, database is one of those software that is more intense, using the CPU intensive and memory intensive applications software. So I mean, if we consider database as a software, it is basically a software where you can store information, but it is mostly CPU intensive and memory intensive application. For that, you do need Elastic Cache. This is exactly like it exactly works like RAM. Now, one more point for the real environment is that whenever you work with the databases in the real environment, so most of the time the database admin will require more and more resources for their database, and this will be you as an architect. So before okay, so if this is the first time you're starting in cloud, you will start as a cloud admin. Later on, 2 3 years down the line, you can become an architect as well. You will become an architect, inshallah. But being an architect, this will be a decision mostly comes to an architect about the databases, that how much resources do you need for this database. So if you've ever worked on a SQL server, SQL server takes up 90% of your memory of the server of EC2 instance, or a virtual machine directly, right from the start. So you'll have to tweak with the memory and resources. So always remember, databases are one of those software that are more on there are more CPU intensive and memory, and one reason is that they should be, because these are very very important databases where reports are running, and then and data is being collected, it is being run, and then it is converted into reports. So now we will be working on an application. We will be working on an application. So once we finish this, the networking part, which is very very important part of a core services of a cloud, then we will start working on a 3 tier or 4 tier application. So I wanted to give you I mean a real experience of that, how a 2 tier application working with a web interface, and then an application, and then a DB. How does it all connect together, and what are the issues and challenges that we face while making this type of database, and where do you connect all these different cloud services like monitoring, notification, and all that. But before, I mean, going into that 3 tier and 4 tier application, guys, we need to become an expert of all of these services so that you can connect them all together. And in order to become an expert in all these services, the only way is practical. The only way is practical. Yes, you do understand everything here. But very important part is the most important part is practical. So for that, the labs are there, and you need to complete the documentation and send it to me. I did receive documentation from two of our participants, and I'm thanking them for taking time out for going through the labs, number one, and number two, completing the documentation. I mean, this will benefit you big time. Ashish, go ahead. You have a question?
Yes, Adnan bhai. Sorry, I probably missed it. Where is the documentation that we actually had to submit? Where's the PDF file? Was there like a PDF file or something? Sorry, I must have missed it.
No, no, no. It's just you need to just email me. You just need to make a Word document,
Right,
and
right.
with the maybe not all of the screenshots, but maybe just a final picture of the
Oh,
complete
right, right.
roadmap.
Of the lab. Okay, okay, okay. Makes sense.
Yes.
All right. So
Okay, good. Yes, Mohammed, you may ask your question.
Yes, I want to ask, what do you mean by two-tier and three-tier?
Okay, so two-tier application is basically an application, two-tier application, two-tier appli. So let's say you have a website. So we have a website, and the website is working. It is working all from this one EC2 instance. Okay, so this is known as just one tier application. So okay, where is it? So this will be considered as I mean, there is nothing like this. I mean, there is no terminology for one tier application. Basically, application that is working from just one server is considered as just hosted application. Okay, what's wrong with my pen here? So two-tier application is when your application is divided into two different services. So for the website, I have EC2 instance, and for the database, it is the second tier. So this is tier one, and this is tier two. So why do we call it tier one and tier two? We call it tier one and tier two because you'll have to manage both of them. You'll have to manage both of them. And why is it important to understand tiering? Because guys, once you migrate this type of application, the migration of this type of application is different from migration of a single tier application. So when you're migrating a two-tier application, you need to make sure that you're bringing two layers of information. So what is three-tier application? Three-tier application is where you have a front end with EC2, where you have a front end of the website, and then you have a database, and then you have application in between. Second layer and third layer is the database. So this is tier one, this is tier two, and this is tier three. So this is a basic understanding of three tier, and even applications are four tier application as well. Now, if the application is three tier application, it becomes more difficult to troubleshoot. So let's say if the website is not working, if the website is not working, it might be an issue in these three tiers. It might be a database issue, it might be the application issue, it might be a web interface issue. So this is why it is important to have a clear understanding of two and three tier application. Okay, and once you go through an example, there will be more understandable. And I'm sure that if you have IT background, definitely you have these. You worked on two tier or three tier application. Okay.
Adnan,
Yes, please go ahead.
excuse me. So just to get a clarification, might be silly question, but so in one EC2 instance, we have a web application, and we have a storage, and we have a database.
Yes.
Plus, we are doing all subnet routing, internet gateway. All these things is connected simultaneously.
Right.
Okay.
So you're saying that in a single tier, no, actually, so single tier is considered as, so I mean, tiering is of many different types. So, but the most common type of tiering is application based tiering. So our focus is on the application. Yes, you have EC2 instance, and I have a website on this EC2 instance. I have a website on this EC2 instance, but networking is still outside. The storage might be on S3 storage as well. So storage is also outside. So it's not necessarily that storage and networking is inside this instance. Then it will be called a single tier application. Is that your question? Does that clarify something?
Uh, you kind of sort of you did, but my and I don't what I wanted to understand was we open one EC2 instance, and then we are adding all these things: storage, disk, and application, web server, and then all the subnetting, routing table, internet gateway, security group will be adding to those to that one EC2 instance.
Yes, in order to work in order for that web site to work, yes, all of these services are required. Yes.
Thank you.
Okay. Uh, so
Can I
guys, yes,
interrupt
please
really
go ahead.
quick?
Go ahead.
So just wanted to clarify. So the IaaS service that you were, can you just reiterate what you were saying about it, please, if possible?
Yes, IIS service is
Sorry, the IaaS service, right? You said it would be tied into the,
IAS.
sorry,
IIS. That is IIS
IaaS,
service.
sorry, yes.
Yes.
Uh,
So
yeah, go ahead, go ahead.
yes, IIS service is a web service from Microsoft. Okay.
Brother,
So
I think maybe he's talking about IaaS, Information as a
Yes,
Service,
there
probably.
you go. IaaS,
okay.
IaaS,
IaaS
yes,
service. So
yeah,
it's infrastructure as a service.
yes.
So Ashish, your question is about what is IaaS service?
No, so you said that it will be tied into just blocks, right? Essentially. So I was just wondering how would it actually work? Like, so you don't actually need like a server present like for running it, or would it be like a in-home server that they would run on the actual program off, and then like I just want to
Yes, yes.
understand the functionality, right?
Okay. Before I can answer this, Ajmal is saying that my voice is cutting off. Is it cutting off for everyone so that I can fix it?
I think it's just for Ajmal.
Okay. Okay, Ajmal, you may connect from your phone. That will be much, much better. Okay. Okay. Sure. So to answer that question, Ashish, IaaS service. So whenever I refer to IaaS service, that is basically whenever you're working with EC2 instance. Whenever you're working with the VM directly, that will be considered as EC2 instance. So for example, in the real environment, when you go to, they would say, we need IaaS implementation of this application. So that means that they would need VMs for this application. So then your next question will be, okay, how many EC2 instance would you need for this application? They would say in the real environment, we have 4 servers working, and 4 servers will be converted into EC2 instances. So that means that that application is totally IaaS based. So this is the point that I wanted to make. Does that answer your question?
Yeah, so does that mean that the actual application will be running off of it? Say, for example, we have a app, right? A game app maybe or something like that. So would it be actually running off on the servers itself, or would they have like the code and stuff totally separate, like and not running on the Amazon server, I guess, right?
No, it will be actually running on that
So the whole
complete
thing.
app will be running
Okay,
on that server. Yes.
okay, makes sense. Okay.
Okay. So guys, here today we are working with networking, and we will be touching base. We will be working with all of the other services that we have already learned in this training. But today's lecture is very, very, very important. It might be a little bit complex for the people who are new to IT. I mean, not in the beginning. I will try to make it very, very simple to understand. So what do we need to learn in networking? So we need to learn in networking VPC. Today we'll be working with VPCs. Today we'll be working with subnets and routers, routing tables, internet gateways, security groups, and ACLs. Before we can start with the definition, the definition is this, but we need to understand what is a VPC. Now, VPC is this is completely so VPC stands for Virtual Private Cloud. It's not connection. Okay, so my fault. It is virtual private cloud, which is considered as, so right here, it is virtual private cloud. It's a network. So today is all about networking. Now, what is networking? So networking, just like in the real environment. So we have something called a network. So what is a network in the real environment? So network in a real environment is computers connected together. So a very simple network can be two or more computers connected together. So would you call it a network if you're working on your, if you're just working on your laptop, would it be a network? If you're not connected to internet, yes, it won't be called a network. It's so one computer is not called a network. As soon as you connect it to a Wi-Fi at home, then you're saying that you're connected to a network. So this is a very simple form of network that we all work with. Now, in all types of network, there are few essential components that are used in all types of networks. So what are those essential components that you work in all types of networks? So for example, so in this, you need to have a computer, number one. Number two is you need to have a device in between that will connect you to the network, and that device can be a switch, and that device can be a switch or a router, and then it connects you to a network. So our home router that we receive from, Rogers, Bell Canada, all these ISPs that provide internet, they will provide us that one box. In that box, it has a switch, it has a router, it has a firewall as well. So it has everything to protect you from the internet. It has everything to connect you to the internet. So you need a computer, you do need a switch or a router, and that connects to a internet. But that doesn't give us a complete definition, of network. But this is just an example of a network that we use at home. Now, so right here, so now, okay. So guys, at any point in time, if my voice is distorted or if you're not able to view the presentation, please let me know. Okay, so guys, you need to give me like 2-3 minutes. My computer is hanging up here. I think I need to shut down few services. So just give me 2 minutes, please.
Can we start overview again because it was cutting out most of the time?
Overview of everything right from the start.
No, VC,
Yes, yes,
VPC.
yes, we will. Okay,
Please.
sure, sure.
Thank you.
Just give me 2-3 minutes, everyone. And so let me fix that first.
I believe there is no sound, brother Adnan, right? Because I see your mouse is moving.
Yeah, I think so. Some issue with this laptop.
Okay.
Did anyone start preparing for the exam yet?
For AWS?
Yes.
No, not yet. Did you complete Azure certification?
Was that for me?
Yeah.
No, I joined late. Yeah, I'm probably gonna do that after Google Cloud, I think.
So I got a question. Are you guys actually studying from like different and multiple places, or are you just like doing it from the dumps?
I do it from that book that I put in the group, and I tried opening the dump, but it wouldn't open for me. I think I have the old VCE player.
So, let
Oh,
me
okay.
let me tell you. We did. Amin bhai send us a Azure in both format PDF and VCE. If you don't have a VCE player, then it's better you open PDF. PDF, you can download PDF, and then you can start preparing your exam. The dump is valid, still
You could
valid.
actually just use the converter, right? When you download the VPC player, VCE player, you actually have a converter that comes with it, right? So you can convert the PDF file into your thing. It's called a VCE designer. You should have it installed with it.
But Amin bhai already did that. You don't need it.
Yeah, no, if you
No,
have an older and different version, right? So you could
yeah,
actually do that yourself. Essentially, you just upload the PDF file into it, or I
yeah.
think so that it asks you to do like a rich format and from the PDF to the rich format, and then upload the rich format, and then you can actually do it, you know, carry on if you
Oh,
want.
I'm gonna try that. It's better to do it on the VCE player,
Yeah,
just because that's how it is actually in the exam. So you
yeah,
see the
true.
questions the way they're supposed to appear,
Yeah,
and
yeah,
then that helps you a lot.
yeah, it does actually.
Because I did all my Microsoft ones like that, and my Citric
Oh,
ones
nice.
like that. So I would say everybody try getting the VCE player.
So you have
Yeah,
a
yeah,
subscription
I
for
got that too.
VCE?
I have an old one. I don't even know where it's from. I try uploading it because I had my Microsoft dumps in there from like 5 years ago. So I don't even remember where I got it from, but the newer ones
So are
don't
you gonna
work on
refresh
that.
your Microsoft like?
Sorry, what was that?
Are you gonna refresh them? Do you have like 2008?
You're cutting out.
Sorry, do you have MCSA and stuff like that? Is that what
Yeah.
Microsoft for?
Yeah.
So are you what version do you have? The 2008? Are you gonna like
I haven't
version?
upgraded yet. I
Oh,
have
sure.
the last one I have was VCE P, I think. Hold on. I gotta check
Oh,
because
true.
it's been like 5 years. So I don't have the newer ones yet.
Oh, true. Makes sense.
Yeah, because I was working, and once you're working, they're really not,
Yeah.
they don't really ask you for it.
Yeah, yeah. So
And
true.
then until you need to go back into the market, then it's hard, right? Because everything changes.
So true. So true. So
Uh,
I think so. The one that you have is probably like not the monthly one, is it? Right? The VCE player.
No, it's not the monthly one. It's I don't even know where I got it from. I
Yeah,
don't
you
remember.
actually have to pay the monthly one. Apparently, Amin Bhai actually had the code for it as well. If you have to land up getting it, right?
Oh, okay. Can I get that code from you
Uh,
guys?
I
Nosheen,
don't know if it's different, but
Yeah.
here I'm gonna
Nosheen,
copy
you've worked
it.
on Citrix?
Sorry, what was that?
Did
Yeah,
you
I have
worked on
Citrix.
Citrix?
Citrix Zenap. Yes.
Oh, wow, great.
Yeah.
So you were
I
working
have
for where?
Bell Canada.
Oh, okay, great.
Yeah, and then I have worked for Canada Pension. I have worked for Dynacare. Yeah, quite a few places.
Nice.
Good.
wow. Okay, guys. Sorry about that disturbance. And so let's see that if it works fine. So it's my other internet. I think there is something wrong with my that other internet. So, but if you still feel like any voice distortion or disturbance, just let me know. Okay, so guys, we are starting with VPC. So VPC is a networking service within AWS. The way it works is the way we need to understand it. We need to compare it with exactly how we know it in the real networks, because everything is in the cloud is exactly the same as the physical network. It's just a terminology that we need to understand. So when it comes to networking, we all know that networking starts from two or more computers. We bring in one server and the second server, and then when we connect this server to a device called a switch, so now a device called a switch is connected to both of these servers. That makes a small network. This is known as network number one. And then likewise, we can have a second network, and the second network connects in this manner where we have a second switch and we connect two or more devices to a switch. That makes a second network. Now, the device that connects the networks together is known as a router. So this is a router that connects these devices together. So there are how many things that we need to know is number one is the computer. Number one is computers that are connected together. Number two is the device called a switch. So computer, switch, and router. So switch connects servers together, computers together, whereas router connects these devices together. So VPC is basically a switch inside, and VPC is that switch inside the cloud environment. So VPC, you can consider this VPC is sitting right here. So when we create a VPC, we are basically connecting all these services together. So VPC is that. Now, by definition, Amazon Virtual Private Cloud VPC enables you to launch AWS resources into the virtual network that you can define. And this virtual network closely resembles a traditional network that you'd operate on your own data center, with the benefits of using scalable infrastructure AWS services. So VPC is that switch. Now you need to keep that in mind. Whenever we create a VPC, we are basically creating a switch inside AWS. So once we create that VPC, VPC to start with, it's not connected to anywhere. So then what we do is then in the VPC, so in a switch, then the second thing that we need to remember after creating VPC is the subnets. So we divide this VPC into small little networks. So VPC is a switch, and by default, you need at least one subnet created in this that where you can connect all your machines. So that logical layer inside the switch is known as a subnet. So we will create a VPC, Then we will create a subnet inside. What subnet defines? Subnet basically defines a range of IP addresses. So it defines a range of IP addresses where all of the computers will be connected to. Now, what is a range of IP address? So before going into the range of IP address, the important definition that we need to understand is IP address. So what is an IP address? So most of us sitting here, we have already, I mean, if you're working coming from an IT background, so IP address is a very, very basic concept that we all need to remember. IP address is a unique number. So I'm just gonna go here with a very basic definition. It's a unique number assigned to all of the computers. So it's a unique number assigned to all of the computers. So without IP address, no two computers can speak to each other. So if we have two servers, these two servers must have IP addresses, then they can talk to each other. Any two devices on the network, they need a unique number where they need to speak to each other. So IP address is that number. So IP address is basically an ID card number. It's exactly like an ID card number when you're in any country. So in Canada, it's equal to a SIN number. It's actually equal to maybe a text number in Australia. It is basically text number. It is everything. SIN number is also in Canada. It's a text number. So wherever you go, it's that unique number. So okay. So Riaz, okay. Sheikh, you have a question?
No, no, no. I'm saying we can hear you.
Okay, thank you.
I can.
Okay, thank you. Okay, so going back to the basic here, number one. So what is a VPC? VPC is that device that connects servers together. So next time, whenever we refer to a VPC, and if I say, let's create one VPC, basically we are creating a switch. And when you are creating a switch, it means that you are building up your own network. And then after creating a switch, how would you connect a server inside this switch? So the very first thing you need in a VPC is a subnet. So basically you need to have at least one subnet where you can create, or you can have 10 subnets or more subnets inside a switch, and you can start attaching these computer together. Let's take a very, very simple example of one server inside AWS cloud. So let's say I create one EC2 instance, and one EC2 instance will be part of one switch, and so this EC2 instance will be sitting inside a subnet, and that subnet will be part of VPC. So VPC is that device where everything is connected to, and subnet is where this is sitting. So once we start creating this will basically make more sense. So here the virtual private cloud, which is a switch, is a virtual network dedicated. It's a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in AWS cloud. You can launch your AWS resources inside the EC2 instance into the VPC. You can configure your VPC by modifying the IP address range. So from this slide, what do we learn? From this slide, number one, VPC is a switch. It's nothing but a switch in the real environment. And once you have a switch, the very first thing that we create is a subnet. And what is a subnet? Just like the word says, subnet, it is a subnetwork. It's a smaller network. It's a definition of a network. And inside a subnet, we connect our EC2 instance or other cloud services. So from this slide, we are taking this information that it's a switch, and switch has a subnet, and then EC2 instances are connected inside a subnet. So you can optionally connect to VPC to your own corporate data center using the IPsec AWS managed VPN connection, managing the AWS cloud as an extension for data center. A VPN connection consists of a virtual private gateway attached to the VPC and customer gateway located in your data center. Now let's take it a bit more further into this. So my question to everyone. Now here, I mean, So how many of us have worked with IP addresses? Please type yes in the chat window. I think most of us have already worked with IP addresses. Please type yes in the chat window so we know what an IP address is. Okay, so IP address is that unique number. It's fine if you've even worked with this. So for now, if you have even never worked with an IP address, just remember that few basic things about IP address. So one is that it's unique. It's a unique number one, assigned to every device. If IP address is not assigned, if you don't have an IP address, then it won't work without an IP address. So the device won't work with an IP address. All devices must have an IP address. Must have an IP address to work together. All devices must have IP address. Okay. Now, so in here, so in the cloud environment, when we are in the cloud environment, AWS or Azure or a GCP, any cloud environment, the very first layer that we are working with is the region. So this is where we are working. So within the AWS account, where it will be, so we just reviewed that in the beginning of this lecture, it's a region. Then within the region, we have availability zones. Then inside zones, we have data centers. And inside data centers, we have all our services. So these all three are logical layers. These all three. So I mean, one of the layers that you see all the time, and we keep that in mind, is the region. So availability zone data center is all transparent to us. So you don't need to worry about this. This is automatically handled. So what we need to know that where is our network, which region are we working in, and the reason why we need to make sure that which region we are working in is because the cost, the billing will be based on wherever you are. So if you're in North Virginia region, the billing will be in that region and all the services will be sitting in that region. If you're in another region in UK somewhere, then for that reason, you need to make sure that region. So right under the region, so you don't need to worry about availability zone, data center. 99% of the time, these will be automatically managed for us unless you start selecting your own availability zone. So in some cases, yes, you would need to select availability zones. So just like in North Virginia, there are 6 availability zones. So the availability zone will be named as, so US East 1A, then US East 1B, 1B and 1C and so on. And then this is availability zone 1. Then within the same region, you have US East 2A. This is second availability zone. So 2B, 2C. So yes, you will be working on, sometimes you would need to change the availability zones, but inside a region. So the most significant layer where you will be working on is the first one is the VPC. So in AWS, you might have a question that we are working in AWS for so many weeks now, but we have never worked on VPC. Can our infrastructure work without a VPC? No, guys, infrastructure cannot work without a VPC. The way it is working by default, AWS already provided us this layer of a VPC automatically for us. So VPC, one VPC. So this VPC that is provided to us, that VPC is known as a default VPC. So meaning that this is a switch. Then inside a default VPC, we have a default subnet as well. So this is our default VPC it started with, and then we have our default subnet. And in the default subnet, once we create a EC2 instance, we already create, so these EC2 instances is created in this environment. So we have a VPC here, number one, which is a switch. And then inside a VPC, we have a subnet, which is a default subnet. And inside a subnet, we create these EC2 instances. So we created that Windows instance and we created that these Linux instances. And inside this subnet and VPC, it has a service that will automatically provide IP addresses. So the subnet is a range of IP address. So these machines are automatically provided with IP address. Now, if this would have not been present, you cannot run and work with EC2 instances. You cannot even connect to AWS cloud. For that reason, to make things simpler for us, all the cloud providers automatically provide a switch and a subnet. Same goes for Azure, same goes for AWS. So this is automatically provided. Now, this VPC and cloud is connected to internet gateway, to a router, and then internet gateway. So from this slide, we need to understand that VPC is a switch. It has a subnet. Then inside a subnet, we have virtual machines that are connected through IP addresses. So three things to remember. So I'm just keep on numbering them. I'm keep on repeating them because this will become the services and components, the networking components are there will be more and more components. So for now, what we know, VPC is a switch layer, and then subnet is inside the range of IP addresses. Third is that VMs are connected to the VPC. Now, the other components of VPC elements, there are some required elements and there are some optional elements. So first required element for a VPC will be a subnet. So you must have a subnet so that VPC can work. So you must have a subnet that VPC can work. This is exactly the same as that in the real environment. So in the real environment or at home, we all have laptops, and that our laptop is connected to Rogers or ISP provided a router. So it might be, so it can be from, this router is basically a switch. So we connect this either through a cable or through a Wi-Fi. So it can, in both cases, your machine must be connected to this router. We call this a router or a router, depending on in UK or American, it's just that different accent, but it's the device that connects the networks together. So we call this router. Whenever you call the help desk of ISP, they would say that, just go and just restart that black box or the white box or whatever the router color is. So you would go and just restart this router. But in this router is also equipped with a switch, because without a switch, no devices can connect together. So router has a switch inside, and inside a switch, it also has a subnet. And that subnet also provides an automatic IP address. So this automatically provides an IP address to us. So now why is this router so, the way this router is configured, this has a router, it has a switch, it has a subnet, and that provides an IP address. This is how we connect to outside to the internet. So exactly in the same manner, since this router is equipped with everything, so that we customer doesn't have to worry about anything anything in regards to the technology. All we need to do, just switch on our laptop. As soon as you switch on, in few minutes you're connected to internet. Why? Because everything is being done inside. So you can consider this as a small little cloud in which all these services are connected. So this cloud has a router, it has a switch, it has a subnet, and that subnet provides the IP address. So basically, subnet is the one that provides the IP address. Now, subnets, you can have different subnets within one VPC. So within one VPC, you can have different subnets. So which means that why would you need to have different subnets? Now the question is, why would you need to have different subnets? Guys, we create different subnets to separate different type of applications. So for example, this is my VPC, and in the VPC, I need to have, so this switch. So let's consider that as a switch. And switch is basically a collection of ports inside, and in a switch we connect our machines, our computers together. Computers or different type of servers are connected to this switch. So VPC also has the same architecture, but we won't work on the switch on this level. This is all maintained by AWS, but in VPC we need to create different subnets. So now that our understanding is, when you create a VPC, you must have at least one subnet, or you can have more subnets. So now the question is, why would you need more subnets? Why does it say the word S here? Guys, in all of the environments, we have subnets for different applications. So we can have one subnet just for our application servers. So this will be application servers. And this subnet is only for databases. This subnet is only for database. And this subnet is only for internet. So this subnet will be only for internet. So these are three different subnets. So this is one subnet, this is second subnet, and this is third subnet. Now, why are we separating these subnet instead of one VPC and all servers sitting together? Guys, this is exactly the same reason why we have streets in our real life. So if we have one huge big street, if we have all one huge big street going in one direction, I mean, so okay, it's a two-way, but going in one direction, then this will be all what do you call, this will be all busy all the time, and this can cause delays as well. And I'm trying to give you a very, very simple understanding of different subnets. So instead of a huge big one big huge street, even in all the localities, we divide that path into different type of streets. So on this street, so both are going in the same direction, but they have their dedicated pipe where they can travel in. So one reason why we have different subnets, because we want to give these application servers full throughput inside this, or we want to provide them with their isolated environment where these machines can connect together. The subnet, so number one is this reason that we need to separate these applications from each other. So application servers separated from databases and internet, number one. Number two is why we have subnets, that you can deploy a separate type of security in each type of subnet. So these application servers are protected with their own door, and the internet is protected with their own door, and the database is protected from its own door. So let's say if someone is hacked into your environment and comes into this subnet, this person will still have to break into that other subnet and then reach your application server. And this person the hacker would have to break into this subnet and go into that. So subnet is also a security boundary. So number one, it's a isolation of applications, number one. And number two, we can have separate subnets for security reasons as well. You want to secure your applications in different subnets. So we can have that different security layers. Okay, so once we create a VPC, then you must have at least one subnet, or you can have multiple subnets in one VPC. Now, how many subnets you can have in one VPC? You can have unlimited number of subnets in one VPC. Should you have many subnets in one VPC? Guys, we will try to keep, even in real environment, we try to keep things very simple. So you need to have a simple architecture unless it is absolutely required. In many networks, you will have in very large network, you can have a VPC with maybe 10 or 15 subnets, or maybe 20 or 25 subnets. But remember, the more subnets you have in a VPC, the more complex it will be to manage. And sometimes making a large number of subnets I mean, it's part of the architecture. So a very small environment would have at least one VPC, with have at least one VPC and one subnet. And in that subnet, you have your servers, you have your databases, you have all your you have your S3 storage, you have your RDS database, you have EC2 instances in one subnet, and this will work fine for a small environment. Or in a little bit architected network, in a little bit designed network, you can have one VPC with few different subnets, and one subnet is for only application server. And maybe you can also divide subnets by You can also divide subnets by type of application as well. So this is application servers, and this is, you can create another subnet that has infrastructure services. So this is infrastructure services. So subnets can be divided in many different ways. Infrastructure services meaning that directory services like domain controllers, DHCP servers, DNS servers, and infrastructure services. Servers are servers that make up the infrastructure, and application services are basically considered as servers that are business related applications. So business related applications, if it is a hospital, then these servers will be having that patient record information or medical application. If this is a insurance company, then they will be having their finance application. So applications are mostly referred to as business application, but in general, we just call them, these are, we have 400 application servers, meaning that they're all business applications are sitting here. And we have 60 infrastructure servers. So our all infrastructure servers are sitting in this subnet. So we create different subnet to isolate different type of application and services. So I would add another word. You will get all these definitions within the same slides. I will upload the slides. Here we need to understand need to understand the core services of network. So we can create different subnet. You can have one subnet, one VPC, everything will work fine. So all your infrastructure servers, all your application servers, all your databases, all cloud services within one subnet, they will all work fine. But you cannot then, you won't be able to provide them different security levels. You can provide security levels, different security groups based on each individual service, but that will be very difficult to manage. So in here, we can have different type of subnets. You can have different type of subnets. So we can have one subnet. So this another example of this, it will be, you can have one subnet dedicated for the public network. So here, let me create that other subnet. So this is a VPC, and most common scenario is this in many of the organizations. So we create a VPC, and within a VPC, one subnet is dedicated to private network and one subnet is dedicated to public network. So one subnet is dedicated to private network, the other subnet is dedicated to public network. So meaning that this subnet is not connected to internet, and this subnet is going out on the internet and connected to internet. So again, keeping in mind that if somebody is able to get into your public network, then they would have to break into that security wall and they can then connect to your private network. So subnet is that. Subnet is a small network inside a larger network. Now, routing table is basically a table that connects different different subnets together. So routing table will be routing table. It's just a table that connects different subnets together. So if this is a subnet, then there will be a routing table that will be connecting these VPCs and subnets together, is known as a routing table. So VPCs, if we need to connect, so let's take a very simple example. If you have two VPCs and you need to connect them together, then we will need to add a route in between, and that route will be stored in the routing table. So it will be stored in the routing. So routing table is a logical table which has the definitions of all of the connections, that how the everything is connected. So it's just a routing table. DHCP options, even in real environment, DHCP option it is just a place where you can connect your VPC to a DHCP server. Now, what is a DHCP server? DHCP server is a server that automatically provides IP addresses. So DHCP option is just says that whatever a DHCP server in your environment, in this setting, you will go and say, my DHCP server is 192, 168, and 10.199. This is my DHCP server. So DHCP option is just that whenever an information comes to a switch, one of the ports is dedicated to DHCP. So this one port will be dedicated to DHCP, meaning that in this port, this port will be connected to a DHCP server. So whenever there is a need for providing IP address, then the DHCP port will say, you need to go to connect to this server and connect to DHCP.
In the cloud or the on premises?
VPC. So in the cloud,
Okay.
yes. Okay, and even in the real environment, all routers have this configuration as well. So router will basically send you, let's say you have a building of 8 floors, and all the 8 floors requires IP addresses. So floor number 1, floor number 2, floor number 3. So on all in all of the floors there are switches connected together. So switches that connects all of the computers together, and what connects the switches is the router. So everything is connected to a router. So this is in the real environment. So here you can consider them as a VPC. Switches are VPCs here, and then the router is the one that connects here, and router has basically the DHCP option as well. So when somebody needs an IP address from here, and it needs an IP address, so this will send an information to a switch. I need an IP address because all devices need an IP address. This switch will send that information to a cloud, and here in the router there is an option called DHCP options. So that DHCP will connect that, send that request to DHCP, and DHCP will provide that IP address to a device. So a VPC, in the VPC we have subnets. Subnets are isolated. You can create one subnet and have all your application, or we can create multiple subnets, just like we have multiple rooms in the house. One room is considered as an office, another room is considered as a drawing room, a bedroom. So just an isolated space for a different type of different type of stuff at home. So in the VPC, we create different type of subnets for different type of application to provide them their own security, privacy, their own isolation for many different purposes. So subnet is just that. So subnet is just a smaller networks inside a large subnet. And routing table is a routing table that connects different VPCs together and different subnets together as well. So from a routing table, we can connect one subnet to another subnet as well. Now, security groups. Security groups are basically security groups. We have worked with a security group. Security group is nothing but a firewall. Security group is nothing but a firewall. Just like in EC2 instance, remember when we create an EC2 instance, in the EC2 instance, we have, okay. Let me bring here. Okay, I'm just bringing the whiteboard here because I need more space. Okay, so what do we understand here? So first of all, we have VPC. So what are we trying to understand? The firewalls. Yes. So inside a network, inside an AWS, we have VPC. And inside VPC, we have two types of firewalls available. Number one, security groups. So inside we have VPC, let's say we have two subnets here. So inside the subnet, we have two types of security. When it comes to a security, there are two types of security. We can provide a security right here, subnet level security. And also we can provide a security group. So subnet level security is known as ACL, which is access control list. So subnet level security that basically protects the subnet. So it is right here. The protection on the subnet level is known as ACL, or the network ACL, which stands for access control list. So this is known as network access control list. So this is known as access control list. So this is one type of security. And the second type of security is basically on the VMs itself. So we create a EC2 instance, and on the EC2 instance, there are something called security groups. In general, both are firewalls. So both type of firewalls. So if I say in VPC, there are two types of, for security purposes, there are two types of firewalls available. So one firewall is known as ACL, and the second firewall is known as security group. So both are firewalls. Now, why am I calling them firewalls? Because both of them, we create rules. What type of traffic can enter into this subnet? So from the network, from right here, what type of traffic you can allow in this subnet. So let's say here you're saying that I need only web services allowed in this subnet. And okay, so what is a security group? Security group we have already worked on. When we create a new EC2 instance, while creating that instance, one of the setting is security groups. And in security groups, if you go in the security groups, you can allow or you can restrict different number of ports. You can, so by default on a Linux instance, port 22 is open. Through port 22, we connect to EC2 instance. And also if we need to connect to a web services, then port 80 is open on this. So basically that security group would allow this type of traffic on this. But if we say, all types of everything is open to this EC2 instance, then there won't be any security. So when it comes to security in VPC, in the switch, in a virtual private cloud, we have for security, there are two types of firewall. There is networking firewall. There is a security group firewall. So security group is based on each individual VMs, whereas the network security group is based on complete subnet. Now, this is in this, so this security firewall is considered as stateless firewall. Stateless firewall. And this is here, it is called stateful firewall. So this is, sorry, this is, where is it? Yes, here. So this is, sorry, this one is stateful firewall. And I'm going to give you a definition. What is the difference between this? So security group is a stateful firewall, whereas ACL is a stateless firewall. Now, what is the difference between? The difference is that whenever in the security group, whenever we create a rule, it will create two rules inside a security group. So whenever we create one rule, stateful means that whenever information goes into the VM, it will, so there will be, it will always be a two-way rule created inside the security firewall. So inside the security group. So which means that remember that when we create a EC2 instance, so here, let me bring an EC2 instance right here. So whenever we create a EC2 instance, what happens is in the EC2 instance, when we go to a security settings, when we go into security settings, and when we say that SSH port is open, and that will be port 22. So it is open for both ways, for traffic going inside the EC2 instance and the traffic that is coming outside the instance. So this is known as stateful firewall. So whenever you create one rule, both rules will be automatically created. This is known as stateful firewall, as opposed to what is stateless firewall. Stateless firewall will be that you'll have to create both rules separately. So if I say that there is an EC2 instance and I need to create a rule for the SSH to connect, for the traffic from outside connected to this instance, in this I would need to create two rules. So at one time with one rule, I can configure only one type of traffic. Let's say if I need to connect to EC2 instance and I'm saying users from outside the network, they should be able to connect to EC2 instance. So first I need to create an inbound inbound rule, and then if I don't create outbound rule, then users won't be able to connect. So I would need to create both rules separately. Whereas in stateful firewall, if you, as soon as you create one rule, I open port 80 on this, the second rule, the outgoing rule, will be automatically created. Now you might say that this doesn't make sense. So this doesn't make sense that if you have one port open, why don't you have the other port open? Now, in order to have a complete communication, you need to have both ports open. So that would make more sense that you would need to have both ports open. Yes, I do understand. Just like a conversation we are all having. So if I am speaking, that you ask a question, I answer it. So yes, in most of the networking communication, you have both. You need to have both ports open. But for a better security, and in some scenarios, you need to have only one type of traffic open inside the network. So it can be because of security settings. You might want to send out traffic to another server, but you don't want to receive anything back. Why are you not receiving anything back? Because there is a risk that there might be some other software that can be downloaded on this EC2 instance uh, that can make some problem in this EC2 instance. For example, if you're backing up this EC2 instance, you just need one type of traffic, that it should just send out traffic to the backup server. There is no need for this server to unless you need to restore anything. So this is one type of service, a backup. Another type of service where you might need only one sided traffic, maybe monitoring as well. In monitoring, you're sending out all the information to the monitoring server, and reports are generated on this type of server. So these are few of the example where you need only one-way traffic and you don't need two-way traffic, so for security reason. So now going back to our concept, stateful and stateless firewall. So in VPC, there are two types of security gates. You can call them gates. Just like in the house, we have a front gate, and then we also have, maybe you might have a gate right at there might be a gate entering into your premises, and then in entering into your house, there is another door. So you have two types of security enabled in your house. Exactly in the same manner, in VPC, there are two types of security that we will be working on. One is known as ACL, which is on the subnet level. So this is more strict. So when it is stateless firewall, it is more strict, because it is because you will have to create each rule separately. You will have to create incoming rule and you'll have to create outgoing rule. By default, this firewall is open to all types of traffic. Just like we have already seen that when we create a EC2 instance in our normal network. So if I go here, currently when we are creating an EC2 instance, that all we need to do, we are sitting at home. So we are all sitting at home here, and we connect from our client computer, and from the client computer we connect to AWS. And in AWS, we directly create an EC2 instance and directly log in. So we directly log in. It means that the firewalls are all open. But the infrastructure, the networking infrastructure, based on our current discussion, the networking infrastructure will be this. So we are connecting to this, but today we are learning that there is a subnet. There is a subnet here, and the subnet is inside a VPC. Subnet is inside a VPC, and this subnet has a ACL here. So this subnet has a ACL that is open to everyone so that we can connect directly to EC2 instance, and there is a security group here as well. So there is a security group on this EC2 instance, that when you create a EC2 instance, we will say we normally port 22 is open to this, and for Windows instances, is 3389 port is open on this. So how many things do we know at the moment? So we know that the network is made by VPCs, number one. Number two, then you must have a subnet. in order for that VPC to work. And subnets can be of many different types. You can have multiple subnets in one VPC. And for security purposes, we can have ACL, which is a network level firewall right here on this side. And then we can have individual firewall on each EC2 instance.
So when you create an ACL, so it will automatically apply to all subnets?
And yeah, so when you create a ACL is basically applied on one subnet. It will be only applied to one subnet. So the second subnet will have its own ACL.
Okay.
Okay.
What is
Yes.
the practice? It's ACL or the security group? What is the best practice in on job?
In the real environment, yes. So in the real environment, it's a combination of all. It's a combination of all wherever the requirement is. So it's a very good question that what type of security would you use? What type of security would you use in the real environment? So the security that we use in the real environment, that depends on different requirement. But the important thing to know is where do you apply network security group and where do you apply use a security group. Now, most of the time, when you have all the common settings within the subnet for one application, then we use ACL. So, for example, so this is a VPC, and in this VPC we have subnet 1 and we have subnet 2. So we have two subnets. So in this subnet, there is all application, all the servers are application related servers. And in this, there are all web servers are all sitting here. So this is a subnet for the web servers, and this is a subnet for the application servers. So if now we know that all these servers would need port 22 to be open. So instead of going into each server and open port 22, what we can do, we can open port 22 on ACL level. So this is one decision on which you can just make sure that, anything, all the traffic that is going into this subnet, this port must be open. And here you need two different type of ports open. So this is a Linux instance, and this one is a Windows instance. So on Windows instance, you need port 20. So on Linux instance, you need port 22, and on Linux instance, you need port 3T89. So that means that in this subnet, you need to do individual firewall settings. So on ACL, we will keep everything open, which is star. We would say all the traffic can go inside, but when somebody needs to connect to this subnet, they need to have this port open. And when they need to connect to this subnet, then this server, then they need to have this port open.
One more question.
Yes.
But in the security group, to manage it, it's very hard. If there is 100 of server, how do we keep the information which server have which port open? So it's really difficult to store.
Difficult to manage and administrate. Yes, it's a very important question. So guys, this is why we have ACLs. This is why we have ACLs. So the question again, going back to, let's say we have hundreds and hundreds of servers, and all the servers have different security requirements. So in order not to go into micro level management, so this can be called, this is micro administration, where you need to go onto each server and then you will open ports. So instead, what we do, we create large subnets, and then we apply ACL to those subnets on that level. But security groups will only be used where there is where it is necessary to be used. So most of the time, security groups are used for individual applications. Mostly in the large environment, you would use ACL, or there will be firewalls. So there is a third layer of security, which is a firewall that connects to internet. So this is a large firewall that connects to the outside world, but inside it will be mostly ACLs that are applied to subnets, so that security settings is applied to all the 100 servers. So Majbin has a question that there was a question, if ACL is open, then security group block on EC2 will block access or allow access. What is the answer to this? There was a question, if ACL is open, okay. So yeah, so guys, the question is, let's say a port is open on ACL and it is blocked on the server. So it is blocked on the server. So port 22 is open on ACL, it is blocked on server. Guys, in security, it is a very common understanding, and here it applies to cloud, it applies to most restrictive wins. So let's say in between this user and this computer, there is a firewall on the network. There is a firewall, I mean, right, starting from your home, there is a router firewall. So we all have a router firewall. So all the routers that are provided from your ISP, it has a firewall too. It's open to everything. It has some basic settings inside the firewall. You can restrict everything. So this is the first level. You go out of your firewall, then you connect to the cloud firewall, so which is a hardware level firewall that connects to ACL. It's a subnet level firewall, and that connects to the EC2 instance where you have a security level firewall. So in all of them, let's say everything is allowed. In all of them, everything is allowed. So here you can connect to port 22, here you can connect to port 22, here you can connect to port 22. And if here it is blocked, in anywhere it is blocked, it is blocked. So deny, so to answer that question, if there is access denied within this chain anywhere, at the end, in the middle, in the beginning, the access will be blocked. So this is a common firewall rule. Okay. Um, Okay, now going back to, so now we do understand VCP, sorry, VPC. And here we have a security group, we have network access level firewall. So here it says it's a stateful, it's instance level. So this is why I said this is EC2 level, and we have network access control layer, which is stateless, which means that if there is two-way traffic, whenever you create one rule, it will be only for one-way traffic. The second rule you would need to create. So this is just to make sure, just to provide a better level of security than the security level firewall. So if you compare, in comparison, this is more restrictive firewall, and this is basically a less restrictive firewall, but still it is a security group. If it is blocked here, you won't be able to connect. Guys, other than these, there are some optional components that connects to VPC. So VPC cannot work without these. So this is a very basic in VPC, the default VPC. I'm going to show you in the next slide that what is the design of default VPC and what is the design of our custom VPC. There is something called internet gateway. Internet gateway is required whenever you need to connect out to internet. So from cloud, you need to connect to internet. We need internet gateway. So internet gateway, just like the word, I mean, there is, you can remember it just from here. Internet gateway is referred to whenever you need to cloud to internet. Now here in understanding, if I can go back here in our architecture. So let's say you have a VPC. Let's say we have a VPC here. We have a VPC, and VPC is connected to a subnet. Subnet is connected to here. Now, if this machine needs to connect to the outside network, VPC must connect to IGA. IGA is Internet Gateway. So Internet Gateway, we will be configuring an Internet Gateway that connects us to the Internet. So without IGA, let's say you don't have an IGA, you won't be able to connect to this. So your question is there an IGA at the moment in AWS? Yes, there is an IGA with which we can connect to EC2 instance and with which we can log into EC2 instance. So at the moment, we do have Internet Gateway, we do have VPC, we do have subnets as well. So next one is elastic address, elastic IP address. Elastic IP address is a reserved public IP address. So this is reserved. This is reserved public IP address. So why would you need an elastic IP address? They would just call it elastic IP address. It's a reserved public IP address, meaning that this IP address will be connected to your one of your applications. So let's say you're hosting a website and that website needs a static public IP address. So you need to buy, normally when you get a website, when you're buying a website from the website providers, so web hosting providers like GoDaddy or AWS also sells out these public IP addresses. So and Azure, you can buy a reserved IP address. So this is just a reserved public IP address where you have to pay charges, and then a dedicated public IP address is provided to you. Now, what happens if you don't have a dedicated public IP address? Guys, as we remember, as soon as you create a EC2 instance, then we are able to connect to this EC2 instance from home. So from home, I would connect to EC2 instance through a public IP address. Remember that whenever you create a EC2 instance, there are two IP addresses assigned to your EC2 instance. One is private IP, one is public IP. So public IP that is provided to us, it's not an reserved IP address. So today we are using one IP address, let's say 3 dot something 46.190 and something. Tomorrow, when you start the same instance, you will be getting another IP address. But in some cases, some applications would need one IP address all the time. So especially for the website needs to be connected to one dedicated IP address. So that if you need that type of IP address, a static reserved IP address for yourself, then you need to pay AWS and they would reserve a public IP address to you. So elastic IP address is nothing but a reserved public IP address. Then we have elastic network interface. So when you get an elastic IP address, you would need a network interface as well. Normally, we have a network interface card on each EC2 instance. So this is not a reserved network card. The reserved network card will be connected to elastic IP address. So this is a network interface. It's just a network card that will be connected to your service where the elastic IP address will be connected to. Then we have endpoint protection. Endpoint protection for AWS services is basically a service where you can connect to all the AWS services from inside the network, inside the cloud environment. So it is inside the cloud environment. Let's say if I have a EC2 instance, if I have an EC2 instance and I need to connect to S3 service. S3 is a bucket, you know. So we all know that S3 is a bucket. So when EC2 instance needs to connect to S3. So let me just explain that endpoint. So what is an endpoint? Endpoint service. Endpoint service. Endpoint service it basically refers to when we need to connect all the AWS services from inside the cloud. So so in order to understand that, we need to understand. So this is my AWS cloud, and I have different regions. So within AWS cloud, I have a UK region, and I also have a US region. So there are two different regions here. Now, if I need to connect my EC2 instance to S3 within the same region, it will directly connect. But if I need to connect to an S3 storage in another region, then then there might be a chance that it might need to connect through the internet. It might need to go out of the AWS cloud, go to internet, and then connect to the UK region, and then connect to S3. Not all of the regions are connected internally. All of the regions, since these are region apart, worldwide regions, the internet is involved. So normally, all of these regions within a cloud provider. So this is all AWS. This is not different another cloud. This is just different country, and they connect to their ISP services are connected together. So ISP of US is connected to an ISP of UK, and they are using their lines. Nowadays, there are projects going on with AWS and Azure and all these. They are actually in a process of deploying their own internet lines between regions. But for now, at the moment, they're all connected through the different ISPs together. So when they are connected to different ISPs together, when you connect your one AWS service from one EC2 instance to another AWS service that is not might be some services in the same region and they are connected through ISP providers. So both cases, if you need to avoid internet, if you need to avoid any internet, so we use endpoints. Endpoints will make sure that these two services are connected together using the back end AWS dedicated internet. So in order to understand this in another example, it will be, let's say I have an AWS cloud, and within the AWS cloud, I have two different data centers. So one data center is in Mississauga city, and another data center is in Brampton city. So these are two different cities. This is city number one, and this is city number two. Now, definitely, so if there is no direct link between them, they will have to go through Rogers internet. So they will have to connect through ISP network. So this is ISP network, and they will connect to internet. And from here, they will connect here. So which means that if you have an EC2 instance in Mississauga city that needs to connect to S3 in that other data center that is sitting in Brampton city, it has to go through the internet, and that would cause some sort of delay. Maybe there might not be a delay, but maybe there is a delay, and also it's a security, maybe it's a security risk as well, but mostly these all services are protected. We can use endpoint protection. So we can say, a connection between this and this will be through a endpoint. Endpoint will make sure that instead of this all traffic going out on the internet, this will be directly using AWS dedicated internet service. So which means that it will make sure that it's not, this traffic is not going out on the internet. This is going inside the AWS protected network. Although this one is protected too, but whenever the word endpoint comes, endpoint is a service that I will show you in the console that we will use. But endpoint using, whenever you use endpoint, it will cost some extra bucks for the use of this service, because you're using this endpoint service so that you can avoid internet for your EC2 instance and S3 connection. So one more time, endpoint protection is to connect AWS services together using dedicated AWS environment. You need to you're making sure that these two services are connected together. So these two services are connected together, let's say S3 and a RDS service. So these are connected together using AWS internal network and not the external network.
So it's like VPN.
No, it's not like VPN. In VPN, you also need a third-party service, but VPN is basically on the internet. This is all inside the cloud. So it will make sure that it is connected inside the cloud using AWS dedicated network.
Okay.
Adnan,
Yes, please go ahead.
like in Azure on the on-premises server, if we install the backup agent, Azure backup agent, we can use that service. Is it possible we can install on-premises virtual machine? We can install this endpoint AWS service and go and access to the S3.
So endpoint service between a physical network. No, whenever you need to connect to a physical network, it will involve internet. So this is why the definition is endpoint will make sure that all AWS services, when they connect together, they should stay inside the AWS cloud and not go outside. But whenever you need to go outside, in order to connect to a physical network, definitely you will need to have connection to internet, and that goes out. So in that,
We can install that agent on virtual machine on premises.
Which agent? The endpoint?
Point AWS service.
Which AWS service?
What do you call it? Endpoint network
This is called
service.
endpoint service. This is just an endpoint
But
service.
can
Yes.
you install and this service on a normal on virtual machine in on premises?
So let me clarify a little bit. It's not an agent. So it's not an agent, so that we're not confused between an agent and this service. Agent is something that is installed inside the EC2 instance. So like a backup agent, monitoring agent, but endpoint is a service. Endpoint works between two AWS services. So it can work between RDS and S3. It can work between EC2 and RDS. It can work between S3 and EC2 instance. So it's a service that sits in between. It's not installed on any one of them. So actually, just to make it more clear, let me show it to you where it is. So if I go here and I go to VPC, so this will be actually answers your question, Ajmal, so that there won't be any confusions. It is a service right here. So this is an endpoint service. So which means that as soon as you need a connection between two AWS service, I would go and create an endpoint here. And when I create an endpoint, it will ask me, okay, so which AWS service you want to connect between. So there are many different AWS services. Here I would say, I need S3. So if I search for S3, it would say, okay, you need to connect between S3 and it is, so this service will be connected using this VPC. And here, what is the policy? So it will allow a policy, then we create an endpoint service. So this is one end. So it's not an agent, it's a service that connects between two AWS services.
Okay, I thought it's an agent. Okay, that's fine. Yeah.
Okay, okay, very good. Okay. So guys, so here this is endpoint. Just I think 5 or 10 minutes more on this understanding. Then we'll jump into the console and we'll start working on VPC so that so that we can see that how this is all connected together. So from this slide and from the previous slide, let me go back here. We know that there is VPC. We need to create VPC. Matchbin is asking a question, is endpoint is like peering? No, peering is a different concept. Peering is a connection between two subnets, and I will explain what peering is. Here you can just remember for endpoint you can say it's like a service that sits in between two AWS service to make sure that their conversation remains in the same network. I mean, in other words, sometimes when we say in our real environment, just make sure that our conversation doesn't leave this room. Sometimes you do have that type of conversation with your manager one time or another. Hopefully in a good, maybe they are promoting you most of the time. I won't say when they are canceling our contract, that conversation also happens in that room. So yeah, it's that type of conversation where you're saying, conversation doesn't leave this room. So endpoint will make sure that communication between it won't leave the AWS cloud. Okay, so just remember that. If you don't use endpoint, can we still have a connection between? Yeah, you can have a connection. So without endpoint, it will go out on ISP and then connect to S3 storage. It will work exactly in the same manner. It's just that here it might be a little bit, so it is fast, but this is faster than this. So it's leveraging inside service. It is secure inside, but then you'll have to pay for the charges as well. So many of the companies would just go with this. If there is some sensitive information, then they go with endpoint services. Then here we have endpoint services. So whenever the word endpoint comes, guys, remember the conversation between two people doesn't leave the room, doesn't leave the cloud. So this is between any two AWS services. So what do we know? So VPC, virtual private cloud, subnet, small networks, routing table. It's a table that connects the VPCs together. We have DHCP. It's just an option to just a pointer to a DHCP environment. We have two types of security security group, and ACL is on subnet level, security group on instance level. Then we have internet gateway. Without internet gateway, you cannot connect your network to the internet. So you must have internet gateway. Elastic IP, elastic network is connected to reserved public IP addresses. There are charges for this. Then we have endpoint services. Then we have private link on for non-AWS services. Then you have private links for non-services. This is so just like endpoint. Endpoint is for AWS services. Then just recently, AWS launched this other service that is called private link. Private link is for non-AWS services, for maybe commercial applications, and this is exactly like endpoint. So private link will make sure that the two applications leverage the AWS internal network. So a private link and endpoint are exactly the same. This is for AWS services, and this is for non-AWS services. Maybe it's between a medical application and S3. It is so it's just for AWS services. Then we have peering. Peering is a connection between two subnets. Connection between two subnets. So we have routing table connection between VPCs. It is a connection between two subnets. So peering, whenever you're doing peering, we will be working with routing table as well, but peering is more focused on routing between two subnets here. So
Two subnets or two VPCs?
no, two subnets.
Because
No. Okay. So it's yes, peering is a connection between two VPCs. Yes, it is.
thank you.
So peering is a connection between two VPCs inside the organization, inside the region, cross region. Peering can connect two different VPCs together. But peering and routing table, they both work together. So this is a routing table information where you can create routes, and peering is a connection between the two VPCs. We have network address translation. Now, network address translation is a service that is used when you need to have certain type of traffic flowing from your network, from one network to another network. So, and then we have virtual private gateway, customer gateway. This is to connect between two different. So there is a full lab on NAT, but here, just for quick understanding, let me try to just clear that concept of NAT here. So what is NAT? NAT is considered as network address translation. Now, network address translation is a device in which we need to connect from one network to another. So let's say here I have network number 1, and it is connected to internet, and that connects to another network. So this is a normal normal functioning. Now let's say I need to install updates. So this is a Windows machine. This is a Windows machine, and we know that on Windows machine, they need to be updated. So where are they updated from? They connect to internet, and from here on the other side, they connect to Microsoft network. And in Microsoft network, there are update services. They deploy patches. We all know that there are security patches that are made by Microsoft that are deployed throughout the world, throughout on all of the servers for security purposes, for features purposes. So most of these security patches. So this is one example. I mean, here you are not having NAT. This server has an open connection from here over the internet, and it is connecting to Microsoft servers, and it's downloading all the patches it is being installed. So this is what happens on our Windows machines at home. So when we are at home, all laptops are automatically being updated from Microsoft, because there is so it's all connected here, and Microsoft is downloading patches. But guys, in a professional environment, in a real environment, this is a security risk. You cannot open all servers to the internet. Why? Because it's not that there might be a legit traffic. There might be some viruses, or hackers can use the same link to basically disturb your environment. So viruses can. So you cannot have this open type of link between internet and the Microsoft of servers. So in that we can use NAT services. What NAT services does, it will open only it. So first of all, it won't expose your networking servers, your servers to the outside environment. So it will look like this. So we have a EC2 instance, and EC2 instance is connected through a VPC. So it's connected through a VPC here. And then VPC is basically connected to, VPC is connected to NAT services. So here, it will be connected to, it will be connected to NAT services, and NAT services connect to the Microsoft environment. So what NAT does in between this, that all of the updates that will be set, that there will be going through is this server, NAT server, and NAT will make sure only that traffic will be allowed inside the network, and it goes inside your network and it is updated on the EC2 instance. So NAT is the service that will make sure that only a specified service, so let's say service on port 80 will be have a VPC. This is exactly the same thing what firewall is doing. Firewall does that. Firewall protects this traffic. But then what is the main purpose behind NAT? Guys, the main purpose behind NAT is that NAT will update not only, NAT will allow this traffic to be connected to not only one instance, but thousands of instances at the same time. So thousands of instances will be connected to internet, but they won't be exposed to internet. So thousands of instances, they all will be connected to NAT without exposing them to internet. So this is what NAT does. So they will be using all the internet services. The only interface that the outside world will see is only this NAT server. So NAT server will be there. If anyone needs to hack into that, they will connect, they will only be able to connect to NAT server, and behind that, they won't be able to see that not millions, thousands of servers are connected to NAT server. This is why it is known as network address translation. The main purpose behind network address translation is security, is to provide security and use of services. So make sure that the traffic can flow this way, and all of these are downloading all of the updates from Microsoft without being exposed outside the internet. Service won't be exposed outside using NAT solution. Have you seen this example in the real environment? Yes, guys, every day we use NAT service at home. At home, we all use NAT service, and I'll give you an example. So the example of NAT is at home, that at home, how many, how many computers are connected together at home? Guys, at home, there are many computers connected. So we get that router, we get the routers from the internet service provider that connects us to internet. But at home, how many devices are connected? Guys, at home, we have our laptops connected. We have our smartphones connected. We have our TV connected, and sometimes there are some other devices, other appliances are connected as well. So how many devices are connected? There are 5 devices connected. But from outside, it will be only one router seen outside this network. So basically, now I'm going to give you the main advantage of this, that on the router there is only one public IP address, whereas all of these devices have their own private IP address. So this one, your laptop might have 192.168.1.10. This might be 1.12. This might be 1.14, and this might be 1.50. So all these devices are private network. They are connected to internet by using NAT services. So NAT is making sure that all these devices can use internet, but they're not exposed to outside world. So NAT is that is why it is known as network address translation. It is translating private address to a public address, Now, if there would have not been NAT, then what happens? if there would have not been NAT, guys, then all the devices at home, they all need to have public IP address. So here you need a public IP address, here you need a public IP address, here you need a public IP address. So number one, there won't be enough IP addresses and there won't be internet now. If there would have not been NAT that was discovered first time back in 90s, they discovered NAT, that NAT needs to be there. So NAT saved the world with that internet crisis. So if there would have not been NAT, IPv4 addresses were not enough for all the devices that needs to be connected. So one more time, since all of these machines need IP addresses, so these IP addresses are provided, are used as private addresses here. NAT will make sure that one public IP address will be enough to be connected outside the network. So NAT is that service. And one example is this. So we all use NAT at home. This is why all the devices are connected to internet. So it's translating private IP to a public IP. So next time when somebody asks that what is NAT, NAT stands for Network Address Translation. It translates private IP addresses to public IP address. The advantage, so this is one advantage, that many computers can connect to internet with one public IP address, number one. And secondly is that without exposing these computers. Now, the hacker who is sitting outside can only see that there is only one machine connected on this router. In reality, there are thousands of machines connected behind this NAT, and they're all connected to internet. So that's what NAT is. So at home, we use NAT services, and in real environments, all servers are connected behind NAT service. They are connected to internet, but they're not exposed to internet as well. So this is our protection. Then there is virtual private gateway and customer gateway and private gateway, private VPN network. So these all services are used a connecting to your physical data center to AWS. So a virtual private gateway, customer gateway, these two gateways will be used between the network. So for example, this is your physical data center. This is our physical data center. And that physical data center is connected over the internet to AWS cloud. So this is AWS cloud. So on this side, on the AWS side, we have a VPG. And on the customer side, we have CGW, which is this. So CGW is this, and VPG. So connecting, so these both services will connect from physical data center to AWS data center or the cloud. So these are the two gateway services, and VPN is the service that encrypts in between, that encrypts this complete communication. So VPN is right here. So so any question, anyone?
Where is the direct connect?
Yes, direct connect is right here in VPN. So either you can have site-to-site VPN or you can have a direct connect in between them. Okay. So which means, guys, this is a very important question. Where is direct connect here? And what is a direct connect? So direct connect is this service. So when we connect from physical data center to actually, this is another point that needs to be understood. So now what are we trying to understand? We are trying to understand what is a VPN and direct connect. Direct connect. And I think this is a service right here. This is direct connect. So direct connect is a service and this is VPN. Okay, sorry. So this is VPN. Now within VPN, what happens is this is a connection. These both services works in between physical data center, and physical data center is so this is a corporate data center that connects to that connects to AWS cloud. So AWS cloud, there can be two types of connection, either site-to-site VPN, or it can be direct connect. Direct connect is a dedicated network that is connected between, it's a dedicated line connected between AWS and your corporate data center. And this is more costly. Whereas VPN is also a connection between your corporate data center and AWS. It is cheaper as compared to this, but as compared to Direct Connect. But Direct Connect is a dedicated link. So the main difference that we need to remember is it's a dedicated connection between corporate data center and AWS, whereas VPN, it's a shared data set, it's a shared connection. Just like at home, these ISPs are selling us with internet with a dedicated connection, a fiber connection. They're saying it's not really one link between, it's still a dedicated connection. It gives you more speed, more throughput, more promises of the dedicated service, and it is more costly. So Direct Connect is that service between corporate data center, which is dedicatedly only for your organization. So it's a ABC organization. They're saying we will provide you with 1 gig connection, 1 gig of a connection, meaning that they will make sure wherever, how many hops they need to go through. Because so what is a hop, and what are the constraints? What are the things that that affect these connections, guys? The things that affect these connections is that there are many ISPs in between. So I'll give you an example. In my last project, when we were migrating, we had a huge problem of slowness. So when we were trying to migrate 400 servers or servers to from corporate data center to here to AWS, actually it was Azure, so it was Azure data center. In that data, so the migration was slow all the time. And why it was slow? Because it was their direct connection. There was so direct connection was not working properly. What is the direct connection? What is that service in Azure that is used for a direct connection? So it's a question for you, if you can remember. Anyone remembers that service in Azure that is used for direct connection?
No, Elastic. No, there was.
Okay, so try to remember from the previous training.
It's endpoint in Azure and AWS.
No, there is site-to-site VPN. There is
Express route.
Which one?
Express route.
It is
Express route.
It is express. It's express route. Yes. Okay. So try to remember from the previous training, but anyways, I'll give you the answer right after, at the end of today, we can remember. Okay, so here in AWS, there is direct connection and VPN. VPN is a shared connection between the two organizations. So the migration was very, very slow because of VPN, because it was shared among other customers. Now, what is the meaning of shared among other customers? Guys, when you connect your company to AWS, there are many ISPs involved. So if depending on which city your organization is, let's say your organization is far away from ISP. So AWS will leverage ISP connections to connect to your corporate data center, because ASP doesn't have lines throughout the world everywhere. So when your corporate data center or your company needs to connect to AWS, there will be many ISPs in between. So it might be that your city is far away and it needs to connect to Rogers ISP, then that Rogers ISP needs to connect to Bell Exchange ISP, then Bell again needs to connect to Rogers, and then it connects to Rogers. So there are these different hops, different exchange. I mean, I'm talking about the physical internet connections, physical internet gateways or the exchanges that are connected together, the ISP exchange. So these are 4 hops here, and the migration was slow because of this shared link. Because these exchanges, are not dedicated for your organization. They have other customers as well in between. So if this is a busy city, they might have thousands of customers here, and you're using the same internet connection that is provided to everyone. So at that point, that company decided, we should go with direct connect. So they bought the direct connect of 1 gig line, and 1 gig line was around maybe 300,000 per month. So, but they were able to afford that, and they got the direct connect. It means that regardless of how many hops you have, it is now AWS responsibility that they will provide 1G connection. So though guys, we need to remember that since it is a city and there are still hops in between, direct connect doesn't mean that there are no exchanges in between. There will be exchanges, but since it is a direct connect, AWS will make sure that the throughput doesn't go below 1 gig, or throughput doesn't go below 500 Mbps. So that's what direct connect is. So sometimes do not confuse that they need to put a line, they need to put a line between your company and the AWS. No, there will still be that, but AWS will make sure that that whatever they need to pay to these ISP, but it will make sure, they will make sure that they will get this connection, this speed, or this bandwidth. Okay, so from this slide, we understood that we need to create VPCs. Then we have subnets, we have routing tables, we have 2 types of security groups. We have internet gateway, we have reserved IP address. Endpoint and private link is to make sure that AWS service stay inside the premises. Peering is a connection between VPCs. If we need to connect one VPC to another. Routing table, it will work with the routing table. Routing table is just routes that we can connect, but peering will make sure that 2 VPCs are connected together. NAT will make sure that your network is connected to internet without exposing your infrastructure. They're still connected to internet, but your infrastructure is not exposed. And what is it translating? The network address translating is, it is translating from private IP address to a public IP address. And then private gateway and the customer gateway is to connect from physical data center to AWS data center. Now, right here, we can see this is how it is connected. What is our time now?
Adnan?
Yes, please go ahead.
Pairing in Azure, we have global pairing and the local pairing. Is it any concept here? The same concept or the
Global peering, so it's just peering. Yes, it's not a local or global. In Azure,
Okay.
yes, in Azure it's 2 different, but here we use same peering for both of them. Okay, so it's a good question here. So guys, in 2 minutes we'll go for a 10 minutes break. So here, so before the break, let's look at this quick architecture here. So this architecture here, you can see this is the architecture where you have AWS cloud. And here we have 1 VPC. So this is one complete VPC, which has 2 subnets. So one subnet is considered as public subnet. The other subnet is considered as a private subnet. In the private subnet, we have our database servers. In public subnet, we have our web servers. And these web servers have private IP addresses. So this is a private IP address, and they're connected to a router, and router is connected to an internet gateway. So internet gateway. So this is a very simple architecture that we will be building in our lab. We will create a VPC, and then inside the VPC, we will create 2 subnets together. Then we will deploy EC2 instances in them. Then we will connect them to a internet gateway. Later on, we will connect them to a NAT gateway as well, so that these machines can connect to internet and without being exposed to internet. So how many things do we know here? We have AWS as a cloud option. We have VPC as a big switch. This is a big switch, VPC, virtual private cloud. And in the VPC, we have different subnets together, and they are in one availability zone. And router is the device that connects the two subnets together. So router refers to a routing table, basically. So this is a routing table here. Routing table only says, it dictates that this routing table it has this IP range, and it's a local IP range, whereas the traffic is open, all the traffic is open to internet gateway. So IGW refers to internet gateway. So guys, let's take a quick break, and right after the break, we will start working in the lab. Okay. So it's a 10 minutes break, guys, freshen up. And so right after the break, we will continue our session.
Adnan, can I ask a question, or you want to
Yes,
take a
please
break?
go ahead. Yes.
No, we want you to take a break too, but I'm just
I will. Thank you.
okay.
But you may ask your
So
question. Yes.
thank you. So it was very long and must be tired. All these things that you talked about right now are the services also, or like you mentioned, I'm not from IT. That's why I'm asking this question. How in the home we have 5 devices, NAT is there, but we don't do anything with it.
Exactly.
Over here in AWS, or we are going to avail that services.
Yes. Okay. So I think the question is that how many services do we need to work on in the cloud? Just like at home, we have a router and we have all these services available, but we don't, configure anything and it starts working. So to for a person that is entering into cloud technology, would say that NAT is already configured over there. So NAT will be already be there. Internet gateway is already there. So most of the time, guys, so since you asked a question, this all configuration will be done by network architect. So you won't be doing any of these in all my projects currently and previous. Always working with a network architect. So network architect are responsible for all these services. Yes, I would assist them with placing the servers, with databases, and other infrastructure, but networking is network architect. But we need to have a very good understanding, so that when they are making changes, when they are discussing or explaining us the architecture, we should have a good idea what they are talking about.
So they might be telling us, okay, I need one router, one VPC, and one gateway. And
Mostly they will do it. It's their responsibility.
Okay.
But let's say if I need to deploy 2 web servers, and they are telling me, this is a different, it's connected to a NAT gateway, and there is no internet gateway on that, and this is a private subnet. So for that, we need to have that all understanding. But mostly it is all done by network architect. There is always a network architect working with a cloud architect or a solutions architect.
Fair enough. Thank you. Please take a break. It's
You're
very
most
long.
welcome. Okay. So
Thank you.
See you after the break. Welcome back after the break, everyone. And okay, so let's type yes in the chat window if you're present, everyone, so that we can continue with the session. So in today's session, what we are doing, so we are working on VPC. So in the example here on the screen, you can see that we have VPC. VPC has two subnets here, and it is connected to. So it is connected to. So one is public subnet, the other one is a private subnet. It connects to the internet gateway and goes out. So for example, if you don't install a internet gateway, then these all subnets will work together, but they cannot go out on the internet. So this is one thing. And then basic definition, we've already been through. VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. And so this is VPC connected to internet and outside. So EC3, VPC provides privacy, security, and prevent loss of proprietary data. So all the networks, they provide these options. Then we have default VPC and custom VPC. The default VPC is the one that the default VPC is created for you by AWS when you create a new account, and then all advanced features are provided by EC2 dash VPC for are pre-configured. So we have already discussed that there is a default VPC. We will be creating our own VPC here, our own network within cloud. So it's a non-default VPC is created to configure by you, but to an EC2 instance. You must explicitly create subnet, NAT, security. So here we need to create everything else. Now, IP address, we have already discussed a little bit about the IP address, and you should have understanding. I would say that understanding networking, if you're very new to the IT environment, I would share with you a few videos on IP address. Just understanding, have a basic understanding. Normally, we as a system admin or a cloud admin, we won't design IP addressing. So you don't need a designing level understanding of how do you convert these IP addresses into subnets, and how subnets, why do you get this number and that number and all that. But we need to have that basic understanding of IP addressing, about that there is a public IP address, there is a private IP address. Private IP address used inside the organization, whereas public IP address is used outside in the public network. So and it's a unique number that is assigned to every device. So at home, all your devices that are connected to internet, they all have IP addresses, and the service that provides IP addresses IP addresses is known as DHCP service. So right here, if I can write here a few things about IP address. So IP address is it's a unique number that is basically required on all the devices. This needs an IP, this needs an IP, and this needs an IP. IPs are provided by our at home. They're all provided by router. And in the router, there is a service called DHCP. DHCP is Dynamic Host Configuration Protocol that provides automatic IP addresses to all of the devices. And sometimes when your device is not working, it might mean that it doesn't receive an IP address and your router doesn't provide it an IP address. So IP address is that unique number that is provided. But within IP address, we need to understand that IP address is made up of two numbers. IP address is made up of a network address and the host address. So in here, we can say that so few numbers are dedicated to a network address. So this will be the network address, and I'm trying to explain just a very basic understanding. And the last number, so right here it has 1, 2, 3, 4. There shouldn't be 5. There should be only 4. So IP address, if IP address is 192.168.10. 10, first three are most of the time are network address, most of the time. So this is a network address, whereas the last one is considered as a host address. So which means that network address meaning, let's say I have a building that has 2 floors. That has so I have a building that has 2 floors, and here we have 100 computers on this building, on this floor, and here I have 50 computers on this building. So these all computers have IP addresses. So these all computers will have IP address, but the network address of this will be different from the network address of this. So here on floor number 2, then the IP addresses will be 192.168.1.0/24. So and here on the in this on the second floor, so on the second floor, it will be this. On the first floor, it will be 0. So here the network address is 192.168.1, and here the network address is 0. And then this last one is the host address. This number is assigned to each of the computers. So this will be 1, this will be 2, this will be 3, but the network address will always remain the same in one network. So this is known as one subnet. So this is known as 2 subnets here. So one subnet for floor number 1 and one subnet for floor number 1, one subnet for floor number 2. One more time, let's try to understand that here. Uh, so easiest way to understand the IP address, number 1, it's a unique number. Unique number that must be assigned. It is made up of that unique number is made up of 4 numbers. So 1, 2, 3, and 4, and in which the first 3 most of the time, and there is a lot of other explanation as well. There are different classes, class A, B, and C, then public. So at this point, you don't need to remember, you don't need to understand, but you need to have later on just go into watch few YouTube videos. Now why am I saying you need to watch few YouTube videos? Why am I saying that? Because guys, this is not your work. This is not even my work as being a solutions architect, because IP addressing is done by the network architect team. But again, when you're discussing with them, when you're sitting in a meeting, you need to have a good understanding of this. Shakil asked the question. So the question, direct connect is between on-premises and cloud. To answer that question, yes, direct connect is always between an on-premises and the cloud. So that's that answer. So IP address is a unique number that is used that is assigned to all of the devices, and IP address is made up of 2 type of numbers. So the first 3 are known as network address, and second last one is known as host address. Okay, and so last one is known as host address. So one more thing that we need to understand, that there is always a number after slash. So why am I explaining this, everyone? Because right now we are about to create a VPC, and then we will create a subnet, then we will need to assign some numbers there. So for that, we need to have this basic understanding of IP address. So IP address is made up of 4 numbers, which we call them octets. So this is IP address. And so the first 3 numbers, so which is 192, 168, and 1.10. So these are known as network. This is known as network address, and this is known as host address. Now, in the real life, we also have our addresses. So we have like a street address and the house number. So this is just like a street number. So here, I'm just gonna just add here. This is like a street address, and this is like a house number. Now, in order to better understand this, so we just understood this one example where we have a building with 2 floors or 3 floors. So let's say we have 3 floors. Each floor, the network address will be different. So network address on this floor will be 192.168. This is 2, and the network address is 1, and this one is 192.168 is 0. So this is a network address. So first of all, when the computer from this floor needs to connect to this, the information will be sent to the switch and the router, and it knows that, oh, this is for floor number 1 because it knows this address. And then there is a last octet. The last number is the host address. So this will be the host address from anywhere from 1 to 255. 254 actually. So there will be in each subnet, there can be maximum 256 IP addresses. There are no more than 256 IP addresses in each subnet. So in this subnet, there are 256 IP addresses. There are in this subnet, there are 256 IP addresses. In this subnet, there are 256 IP address. So now that we know that first three are the network address, which floor, which location, which city, so that is basically the physical, that the first three numbers are like a street address. So each street name is different. And then so each street name is different. So Riaz is asking a question. Is there a question on IP in the exam? I think there might be few questions, but there won't be questions of this type. Divide the IP addresses and what are the classes of IP address. I don't think there won't be any questions on that, but there might be questions on subnet. So there will be already defined IP addresses. If your VPC and subnets concepts are clear, then you will be able to understand the question and just go through the exam. So in here, so one more time, guys, we are trying to understand IP address. IP address is made up of 4 numbers, and 4 numbers are divided into 2, just like our street address is divided, network address and host address. And in this example, we have 4 floors. So the network address is different. This is 0, this is 1, this is 2, and then there are host IP addresses. Now in each one, now the important thing regarding, so this is exam question as well. This is exam question as well, that from 256 IP addresses, how many IP addresses are available to be used in each subnet? So guys, there are 5 IP addresses on each subnet are reserved by AWS. So first 5 IP addresses are reserved by AWS network service. So rest of the IP addresses, which are around 251 IP addresses are used within the subnet. So first 5 IP address, you cannot use them. The first 5 IP address in AWS will be reserved by AWS services. So there are total 256 IP addresses. Now, one more thing that we need to understand in this is that there is always a slash after an IP address. Whenever you create a subnet, you need to put a slash and you need to provide this IP address. So this slash, after the slash, it might be 16, or it might be 28, or it might be 24. So one of these 4 numbers, it can be many different variations of these numbers, and I will show you in the other slides as well. But these numbers basically, these numbers basically for a cloud admin, we need to remember that if after the IP address it shows as number 16, it means that it is a complete, it's a bigger subnet. It's an address space. So this is known as a address space. Address space, and there is a logic behind this, and I'll let you know. So first of all, this is the main subnet, which is the main network. So I would say this is main network, whereas this is the subnets. This number is used for each subnet. This number will be used for each subnet, and this number is specially used for a gateway subnet. So this 28 number, if it comes after IP address, it won't be used for so this number won't be used for a subnet. So now just by understanding this, so if I say this is one subnet, right at the end of this IP address, there will be 24. So 24 meaning that this is just dedicated to one subnet. If I put 24 here and 24 here, this means that this is one subnet. So 24 means one subnet. many of the people who are sitting here, they already have a deep understanding of IP addresses. They all know that 24 means that 24 bits are on, and that is on the network side. But as being a cloud admin, you don't have to have that a big understanding, but I'm giving you that understanding that you need, that you must have at the moment. So if after an IP address it shows 24, it means that it is showing that it is a complete one subnet of this. So this is one subnet, this is second subnet, this is third subnet. But here, if I want to put 16 here, 16 will be it will be showing one complete network. Now let's look at this right here. So in here, so our architecture. So let's look at this here. Now here, this means, so keeping in mind that 16 shows the main subnet. So this is the main subnet 10.0.0.0, saying that everything that that comes into this network, this numbers are for all the hosts that are using this, and this denotes that this is the main subnet. Whereas here it's saying that this is 24. It is only that blue line. So 24 number means that this belongs to just one subnet. So 24 is one smaller network. 16 is a larger network. It has more IP addresses. Okay, so in the lab, what we need to do, everyone. So in the lab, this is what I'm gonna do, and please log into AWS. So the first lab, just like all the time, the first lab I will show you. In the first lab, we will create a VPC, and then we will create two subnets. So this is what we need to do. This is what we are doing at the moment. And so we are logging in. Everyone log into AWS. Let me know in the chat window if you're logged in, please. So in AWS, we already have default
Need
VCP,
to log in as
but
an IAM user? Sorry.
yes, IAM user, yes.
Okay.
You can use root as well, but it's better to use IAM. So Mejbin has a question based on IP address. They will ask question saying, can these computers connect? Okay. Okay. Yeah. So yes. So those type of questions. Yes, that's good. Better use IAM. Yes. So so once you're logged in, let me know that if you're logged in. So everyone logged in. Now what we will do, we will create a VCP here. So I'm gonna create a VCP. And guys, it's also important to remember these icons as well. So whenever you're working with this, just use icons. And I would say that when you document your labs, also make an architecture diagram, because for a cloud architect, it's good that if you are able to understand the icons and the way they work together. So if you can architect them, you can use website called draw.io. Draw.io website will, there you can create architecture diagrams. So in this website, you can create architecture diagram. I would say, guys, honestly, please complete all of the labs and also document the lab as well. This is very important for your real experience. It is very, very important for your real experience, because without doing this practical, it won't be easier for you to remember and explain the services in the interview. So in the interview, if you need to explain the services, so here if I go to cloud, within the cloud, it shows me already these all different types of templates. You can use one of the templates here, and so they keep on increasing more and more, adding more and more templates here. So for example, so this is one of the templates. So when you create these, So it will give you a template and it will give you some exposure. So when you're creating a document, try creating a diagram as well. So here, the icon for the VPC is this. So in the lab, this is what we are going to do. We will create our own VPC, number one. And number two, we will create two subnets. We will create two subnets. So one subnet is public and one subnet is private. Okay, so one subnet is public and one subnet is private. Now for the VPC, it will require an address space to start with. By default, it automatically provides us this address space. So which is 16. So inside this VPC, all the IP addresses will be from this address space. Can you have your own address space in that? Yes, you can have your own address space as well, but then you'll have to come up with your own IP addressing. So I would say for all these labs and even in the real environment, when we create private network or maybe for dev test, we will go with default address space. And the reason why we would go with this address space, because this is if you go with this, then AWS would automatically provide different examples based on the same IP scheme. So I would say just use the default address scheme. You can use your own address. So for example, if you just want to put something else, 11 or 12 or something, some other number, you can do that as well. But we are going to use this address space. Now here, our VPC will be this address space. Our public network will be, so I'm going to use for the public is, so here I'm going to write public will be 10.0.1.0/24. For private, it will be 10.0.2.0/24. Najmin is asking a question, can there be more than one VPC with same address space? No. No, there cannot be. So you cannot have, you cannot in the same cloud, you cannot have, you can create your own VPCs, you can create your other address spaces other than this. So one address space can be used once in the complete one network, not only in one cloud. In one network, it can be only one address space. Sorry, in one VPC. Then when you create a second VPC, you need to provide your own another address space there. Okay, so this subnet, public subnet will have this subnet, and in this, once these are made, then we will create then we will install VMs inside. So in this, we are going to install two VCs, two EC2 instance. And here we will install two EC2 instance as well. So one EC2 instance is Linux and one is Windows. And here one is Linux. I'll come back to your question. So here, yes. Yes, please.
The question is like, sorry, the thing is, if we leave this VPC created and we don't delete it, is it going to be charged?
No, it won't. It won't charge, but it's better to delete them. Because why? The reason is that there might be. So when you create a VPC, when you create a subnet, there are no charges for this. But sometimes you don't clean up. What happens is there might be some services that we are working with are on, and that those services might be charged.
Okay, thanks.
So here, so guys, this is what we're going to do. Let's do step by step. So first we'll create a VPC and we will name it, we will name that VPC something. You can name it anything else. I'm going to name this C60 Cloud VPC. VPC, and here the subnets, you need to name them and also provide these IP addresses, and then we'll go from there. But okay, so since we are here, so one thing that we need to understand before we can start here is here is our, where is that device? So I don't have that icon for this. We also need a network gateway. So we need, so once this is all done, this is step number 1. Step number 2, create subnet. Step number 3, create VMs inside, and VMs will be in this VPC and subnet. And then we will create, so there we will configure a routing table. and routing table, and that will be connected to IGW, which is Internet Gateway. So this is how it will be connected to. So internally, these two subnets are connected, but only the public network will be connected outside. So this will be our architecture. So only the public network will be connected to the internet gateway, whereas internally these two are connected. So which means that if we need to connect to these computers will be connected through this. So first we'll connect from home. We are connected to internet gateway. We connect to any of the machines here, and from this machine we will be connected to this. So that brings us to security. We need to place a security here on these subnets to allow the traffic, and also we need to configure our security groups here as well. So let's start with this. So once we are logged in, this is what we need to do. So I'm going to go back to services. So you need to go to VPC first. So right here, you can go down in this, and in this section, you can find VPC right here. So this is VPC. If this is not in your recently visited services, in the VPC, here you will see everything. So how many VPCs you have, how many subnets you have. So by default, you have one VPC and 6 subnets and one routing table, one internet gateway. And because of these, we are able to connect to a EC2 instance. So as soon as we create a EC2 instance, we start connecting. Why? Because there is already one VPC, one subnet, and one routing table, one internet gateway. There is a security group. There is one ACL as well, and there is no NAT gateways. There is no peering here. So in order to create the VCP, we will go to your VCP. So first of all, go to your VCP, and in this VCP, it will show us the default VCP. So this is the default VCP where we are connected, and the address space it's using is 172. So it's using for its own purpose. So this is the private address space. So we won't be using this address space here. And this default VCP, so first of all, let's rename this. So I'm going to rename this default. So I just renamed this default VCP so that we can remember that this is our default VCP. Now within this I'm saying I'm sorry about that. VCP, sorry, I'm confusing that with VMware. Okay, yeah, VPC, I'm really sorry, thank you. So VPC, default VPC here, everyone. And so this is a default VPC. If you go into the details here, in the details, it shows us that this is the network ACL connected, this is routing table connected, this is DHCP options that is there, this is the CIDR value. CIDR is just this notation where it shows the complete address space as with /16. So what we are going to do, let's create our VPC, create a VPC. When you're creating a VPC, we will name it /360 Cloud VPC 01. And the address space, as you can see, it's a little bit blur here, the blur address space. So this is recommended. So we are going to use with this address space. So CIDR block is this. We can either go with this or 16. It is recommending, why is it recommending 24? So it's saying that 16, we can go with 16 address space if we need more. So I'm gonna go with 16 here. So 10.0.0.16. So it's recommending 24. It's thinking that it's just we are creating one subnet, but since we need to create more subnets, so that's why this VPC we will be configuring that with 16, because we need more subnets. 16 means that it will be an address space, and in this we will be, if we start with 24, then you won't be able to create more subnets in this. So for that reason, we are doing 16 here. Within IP IPv6. We don't need any IPv6 for the people who are new to IP. Guys, IP addresses are of mainly two types. There is IPv4 address. If you can see on this side of the screen, you must specify IPv4 address, and there is something called IPv6 address as well. IPv4 is an older type of IP scheme, and IPv6 is a newer type of IPv scheme. At the moment, IPv6 is not used most of the places throughout the world. If you can say, IPv6 is only used in 20% of the countries. IPv6 is not used in rest of the 80% of the companies. They will start using it, I don't know when, but IPv6 is there. So IPv6 is a newer scheme. IPv4 is older scheme, but it is still in use, and it is, I mean, it is required to be used. Now your question might be, if this is a newer scheme and this is older scheme, why is it not still used, and how old is this? So IPv6 was introduced like maybe 10-15 years back, whereas IPv4 comes from last 30 years, 30 years back. IPv6 is not used in most of the places because it requires a complete infrastructure change. If a company needs to have IPv6, they need to change their routers, their switches, and they need to change their infrastructure. Then they will deploy this. For that reason, many of the companies are still using IPv4. So for that reason, we are not selecting anything here. In case if that company is using IPv6, they will select it. Who will decide this? Network architect, not our decision. So if they say, we need to do this, and yes, okay. So that's one question that came before, that what is our role in networking. So one of our role is that probably your network architect might not be a cloud expert. So your network architect might not be a cloud expert. He might sit with you, he has all this information, but you might need to fill that up. So he would say, my address space is this. So whatever he says, so your network architect might not know that where to go and create a VPC, and how to create a subnet and all that. This is our task, but they will be providing us all this information. Okay, for the tag, it's the name tag, that's it. And we will create that first VPC. Okay, so where are we? So first we have created our first VPC here. If I go into your VPC now, in your VPC, we have two VPCs here, the default VPC, and this is our VPC. Now within this VPC, if I select this, in this VPC, so how many of you were able to create a VPC? If you are able to create a VPC, just type created or yes. If you have created it, uh, if not, it's fine. You can have a look at it, and it is being recorded, so you can redo that on your own pace. But I'm moving a bit slow, but I have to move fast in this later on, because I will be adding a lot of services, because it requires some troubleshooting as well, and the time we have might not be enough for all of the troubleshooting. So, but still, I want you to go through some basic understanding, a basic practical exercise. So let me see the time here. Time is 9:47. 9:47, we have 45 minutes to go. Okay, so from here, because I need to show you a full picture, if I'm moving fast, just and this will be all recorded, and I will provide you with a recording as well. So if you're not able to catch up with me, it's fine, but I have to move fast because we need to make it work. It might not be that simple for you to form it. So if you're not following me, it's okay. So guys, here I've created a VCP based on our requirement. Number one, VCP is ready, and now I need to create two subnets. So I'm going into subnets here, and within the subnet there are already 6 subnets that are default subnets available whenever we create VCP, EC2, or any other service that requires IP address. So I'm going to create 2 subnets here. So the first subnet, when I create, I'm going into the subnet one more time. I'm going into the subnet. Most of the things are logical, and you can just by looking at the screen, you can follow along as well. So I'm going to create a new subnet. and I'm going to go to VCP. It's saying which VCP you want to create the subnet, and the one that we need to create a subnet is in this 360 cloud VCP. And once we are here, it's saying your address space is this 16, and the subnet name. So the first subnet name is a public subnet. So remember that we need to create a public subnet. So this is a public subnet 01. I just name it, I just number it. I mean, it's not required, but I just number it so that if in case we need to create another same subnet. So public subnet 1, and here availability zone, you can select an availability zone from here. Availability zone meaning that you can connect to any of these availability zone, one availability zone or another. So for now, we have no preferences, so automatically it can select. And here is the address range. Here is the address range for this subnet. Remember that you're creating this this subnet inside this VCP. So the address range will be, it is automatically giving us this example, and it is 10 dot 24. So I'm going to go with 24 here within this. So I provided the name, no, nothing in.
Sorry, Adnan, my screen just lagged a little bit. How did you get here?
How did I get here? Just go to subnets and create a subnet.
And by public is 1, the 0.1, 10.0.1, and private is 10.0.2.
Oh yes, in our case, yes, it is. Thank you. We can start with 0 as well, because 0 subnet is not used, but since in our architecture we said it is public is 1, so it will just go with our architecture. Okay, so everyone, I just went into the subnets and create a subnet. I just provided a name and then provided the value based on our architecture, and then rest is just tagging here. So name is already provided, and I will create this subnet. So one subnet is created,
Adnan?
and it's, yes, please go ahead.
I know you had to go faster, but it didn't took a name. Do I have to practically put it in a name in there?
Yes, so I'm going to create the second subnet now, and you can follow along. So
Okay, thank you.
once you create a new subnet, then you would select VPC, and name is right here. Once you select a VPC, then it will ask you for the name. Are you on this screen?
Idnan, can you go back a little?
Yes, yes, I will.
Yeah, I think my screen is totally a little bit different than what I see on yours.
Okay.
So
Okay.
essentially, just in the subnet name is what we have to name it, and in the IPv4 is the same IP that we provided for the VCP.
IPv4 address will be the same as this. So just a second here. Let me
As
show.
the Cloud 360 or
So
no?
here, our VPC subnet, our VPC address space was this. Okay.
Right.
And public address space is 10.0.1.0
Oh,
slash
right.
24.
Makes sense. Okay. So
And
access
private is
okay.
this. So we just need to, so first we created a VPC. I already
Right.
created a public subnet. Now I am about to create a private subnet. Okay.
Okay.
So the way we do it is all we need to do, go to subnet and then go to create a subnet. So once you create a subnet, and so once you're here, all you need to do is select the VPC. And VPC once selected, then here you need to provide the name of the subnet. Okay, so I'm saying that this is private subnet 01. The other name was public subnet 01. And so these are two very simple things. So we did it in 3 steps. One, we went into the subnets, we created a subnet, and then we selected VPC. And then here I named it. And the only technical thing that we need to do is to know which number do I need to put here.
Idnan, I'm sorry, my screen is different.
Okay, your screens are different. Yeah, I mean, that is, okay. So what I'll do is, let me create these here, then I'll connect to one of your screens because it might be the way we are connecting from. I'm connecting from Sydney, you're connecting from Canada. So that might made a little difference. Strange, but it shouldn't be though.
Also, the region makes a difference because I am in North Virginia.
Even I'm in North Virginia too. It might be that secret that AWS is having, that they have a different portal for different places. That's strange. It shouldn't be the
Like she
case.
was saying that the screen she was looking at it, maybe we have the same issue altogether.
I have the same screen you have. The
Okay,
same.
you have the same screen. Okay, and Nosheen and Riaz both have different screens. So Riaz, you're accessing from US, right?
Yeah, no, I had a different screen
I am.
as well, but I was going
I am.
through a different to create a VPC. So we have to
Okay.
go from the one on the left side, not from the right side.
I did the same thing. I went on
Yeah.
the left.
Yeah, so from the right side, it took me to a different screen.
Yeah, but I'm on the screen says create subnet is a name tag, VPC, availability zone, VPC CIDRS. That's what I
Yeah,
see.
same screen like Adnan.
Okay. Okay. So let me quickly create
Okay.
these two subnets, and then I will connect to maybe Riaz. You can share your screen, and then we'll do it on that screen as well. Okay. So
Thank
that so it's easier for everyone. So for this subnet, I am providing 10.0.0.2, 10.0.0.2.0 and /24 and create a subnet. What is wrong with this? Okay, this is, yes. So this is the IP address, create a subnet. So we have created two VPCs and we have created two VPCs and one VPC and two subnets. Okay, so now Riaz, would you be able to share your screen quickly? So I'll provide you, all you need to do is to click share on the screen.
I did. It's taking time. So
Okay, that's fine. So in the meantime, everyone else, once your subnets are made, make two EC2 instances in each subnet. So make sure when you create a EC2 instance, so one Linux, one Windows in both subnets, when you're on the screen where it asks for VPC and subnet, select your own VPC and the subnet. If you're not able to do that, just hold on to that. Right after this, I will do it.
So essentially, just go to EC2 and create a machine and give it the subnet that we just made, right?
Exactly. So two
Okay.
EC2 in public and two EC2 in private.
Okay, perfect.
Okay, so I can see your screen, Riaz.
oh,
Can you
perfect.
change to your
There you go. Can you see now?
no, we cannot
Oh.
see your screen.
Maybe in the second screen, if you have dual monitor.
Yeah, maybe you're on the second screen.
One second, please.
Okay, that's fine. And maybe Nosheen, if you can share your screen, because you and Riaz both have same screens. So Majbin is saying that I have the same screen. So Majbin, you have a same screen as my screen or the other screen? Okay.
I don't know why this guy.
Just click on the tab above the internet, just beside Zoom. Create VPC where it says create VPC on your Internet Explorer or Zoom. Yes. Okay, so we are here now. You have the same screen as mine. Okay, can you create, so hold on. So just go to subnets. Okay, so once you're here, can I take over, please?
Please.
Okay, I can. So right here, I'm gonna go and create a subnet. So once you're here, it is, I'll create a subnet. Yes, this is, okay. So this is Nasheen's screen. Okay, so first of all, when we are creating a subnet, I'm gonna call this public subnet 01, and the VPC that I need to select is our cloud VPC. And how do we know? Because we tagged it. And the CIDR value is this. And since this is a subnet, we need to provide the CIDR value of. So this will be the CIDR value. Okay. So just 3 things here. And I think this one is a simpler than mine. I had so many options there. This is just the name and the VPC, the availability zone, and the IP address. So once it is done, so first subnet is created, and second subnet, would you like to create your second subnet?
Sure,
Please?
I'll do that. I just didn't know because ours looked different than
Okay,
your screen.
okay.
Thank
Okay.
you.
You're most welcome. Okay, so Shakil, would you be able to do that now? Sorry, was that Riaz or Shakil having the
Shakil has
screen?
already done.
Okay,
Shakil
Shakil
has
is
already
already done. Sorry about that. So I think it was Riaz's screen. Okay, so once Riaz's screen is available, then we'll kind of do that.
I'm trying to connect it. For some reason, it's not allowing me. So if you go ahead and move on.
Okay,
because
okay, that's fine.
Sorry about that.
Okay, no problem.
So under each, sorry to interrupt you. So under each private and public, we need one Windows and one Linux.
So yes, on both of them, we need one Linux and one Windows. Yes.
Okay.
Now, so this is what I'm
Brother,
doing now, everyone. Yes,
Brother
please.
Adnan,
Yes, please go
you
ahead.
know that creating that VM and I mean EC2, we have already done it, right? Rather than maybe we should look into like that we have to associate it with gateway and whatever all the other things are there. Can we go there maybe?
Without the VM, you won't be able to test the VPC. So this is why I'm doing it. I'll do it quickly. I'm just asking you guys to do it on your side. So I'm just doing it now quickly. I need just 2 instances. The main thing in here is that you should know that where to connect your instance. So I'm gonna just launch 1 instance in public and 1 instance in, and then we will definitely configure the gateway as well. Because without gateway, we won't be able to connect outside. Okay, so I am selecting Linux instance. And in here now we are in the networking settings. So we're not going with the default, we are going with our own VPC. And since this is a public, this is why tagging is very, very important, because without tagging, you have these numbers and that doesn't give you any information. So I'm selecting here public subnet. In the network, I've selected my VPC, and I do need a public IP address in here only on the public network, not, so I want this. So this is a very important difference that we need to remember. Other than that, we also need, so this is instance, and here it is also providing us the Ethernet settings. So we'll
On
leave
the private one, we don't need to enable that feature.
we don't need to
for
enable this feature, assign
thank you.
public IP. Okay. Now in here, we'll just, for the sake of this lab, I'm gonna add our script. I'm gonna add our script so that it should install, and sometime it works, sometime it doesn't. So if it doesn't work, all we need to do is to run this one command, logging in. So that will make it a web server. Why do we need a web server? Because this is how we can test if our VPC is working. So I'm gonna copy this. I am going to copy this in the chat window so that you can all use that on a Linux instance. So just put this script inside the bootstrap so that it becomes a web server, and sometime it works, sometime it doesn't. If it doesn't, it's fine. So the next storage, we don't need to make any changes. On the tag, I do need to provide a tag for this as being, this is a public web server. So that I know that this machine is for the public access, is configured with the public access. On the security group, I need to create a security group. I need to name the security group as public as well, because everywhere where I go, I need to see that this security group is used for the public access of this VM. So this is my public security group. So I mean, so this might be a lot of changes that I'm doing, but it's not a lot of changes. It's just that everywhere within this VM, I'm adding the word public so that I can remember that this group is for public access. Now, since this machine will be a web server, I will be adding a rule for HTTP. So I've added a rule for HTTP, and that's it. All I need to do is review and launch. Yes.
But security group, is it a security group instance level or a
This
instance
is
level, right?
instance level. This is instance level. Yes.
Okay.
So Adnan bhai, you just changed the name, right? Or did you add another rule for? Can you just go back one step if you don't mind? Sorry.
I changed the name of the. I just changed the name of the security group.
That's it, right?
That's it. So that I know that this is that security group. So
Right,
this machine is in that subnet, and I'm gonna create another machine as well. Okay. So everyone, if you don't have a question, we can mute our mics, and you can always unmute your mic. So I'm going to create the second instance, and this second instance is again a Linux instance, and this will be sitting in the other subnet. So it's just another Linux instance. So on the second instance, yes, public IP will be disabled. So this is the second instance, and make sure that it is in our VPC and it is in our private subnet. So this is in the private subnet, and here it is, we don't need a public IP address for this, because this is why we have that other subnet. So this is why we are doing this lab, because we need to understand that once we create VPC, you need to make sure that these settings are proper. VMs are sitting in their proper network. So once this is done on this, I'm gonna again copy the script. And I'll just make sure that in the script, everything is small letters, number one. And number two, we have proper commands in here. You don't need a sudo command in this. It's just that these machines will be connected. Okay. And in the storage, we don't need anything in the storage. In the tag, I do need to tag this as private. So this is private Linux instance. In the security group, I need to name it private security group. Now, why this tagging is important, guys? It is important because when you have so many cloud services working, it's the tags that let you know which service you are working with. If you don't use tag, your services will still work, but it will be difficult to track them. It will be difficult to work with a specific type of service at one point. Okay, so the second instance is launched as well. So now I have two instances here. So now based on our architecture, we'll keep looking at our architecture. Our architecture, we did created a VPC. We did created a public subnet. We also created a private subnet. And then we created one Linux machine in public subnet. So it is sitting exactly here. And one private subnet is one private Linux instance. So now we also need one Windows instance as well. So quickly, I'm going to create that. So Windows instance, I'm going to go with base.
Did you open that HTTP on both the Linux machines?
On both Linux machine, yes, it is. So both will be web servers, and that's how we will connect to them.
Okay, thanks.
So one Windows machine will be sitting in public, and one Windows machine will be sitting in, so same settings. So first Windows machine will be sitting in the public, and it has a public IP address. There is nothing in the bootstrap here. And next. And disk, we don't need to make any changes to the disk. Tagging, I do need to tag it. So this is public Windows. Instance, and within the security group, I do need to what we can do is I can create a, this is for the public Windows security group. Or what we can do is we can select the other security group as well, the one that we made public, but this doesn't have 3389. Okay. So guys, here, we have two options. I can create a new security group, or I can connect it to the existing security group as well. So creating a new security group is easy. Everyone understand that I can just rename it and create it. But you should know how to work with one security group with all of your instances. So if you don't need to keep on creating security groups, and you need to work with one security group that can work for all, you can do that as well. So in this case, I am going to create a new security group for this. This is public Windows security group, and the two ports that I need is this, and I'm going to name that as well. And nothing else is required, and this can be launched. So quickly, I'm going to launch the fourth server in the other subnet. So in that, I am going to select the VPC. This will be the private Windows machine. We don't need an IP address so that this machine is not accessible from internet. And storage not required. In the tag, quick tag. Private Windows. Security group is this. So in here, and I'm going to add one port for port 80. So once this is done, it's launching. Okay, so now we'll go back to the instances, and our architecture is complete. So our Linux machines are done as well. And I'm not sure why it didn't tag them. So this one, so this one, let me go here. So we did tag them. So the security groups are tagged properly. We also tagged the machines as well, but the names are not here. I'm just gonna quickly name them.
when we tag, in the first column we have to put as name, and then in the second column you put the name, and it comes okay.
In the first column, you're saying when you tag?
That, yeah, you put the N, press NAME, then on the name first column, and the second column you put the name and tag.
Okay. So this is private Linux, and this one is, so how do I know that which one is private? Because here you can see with a private public IP address on one of them. So this is a public, yes. Okay, and here this is the Windows one. So now we have 4 instances. Now, first of all, let's try to connect to one of them. We have our VPC and we have our subnet. So we can only connect to one of them. So I'm going to connect to the public one. Yes.
Brother Adnan, can you hold for a minute? I'll just finish, then I'll watch the screen. 1 minute, please.
Okay, no problem.
So meanwhile, Adnan, the reason you gave the names over here because you didn't put them in the tag over there in the when we're doing creating a instance.
No, I did the tag, but I did I think I did the other way around, where I need to put the name label. I put the name of the machine. So I had to do it correctly. It was incorrectly done.
The one was talking about. Understood. Okay. All right. Yes. I just want to make it understood. Thank you.
So connecting to Linux instance is the same way that we connect to all our instances. So here it's the same way that we connect. So it's nothing new for everyone. We would just go here. There are few ways to connect to Linux instance. You can connect it right from here, from where we are accessing it. And let me try to connect from here, or we can use a PuTTY client. From there, we can connect as well. If I try to connect right from here, so here, if you try to connect, most probably it won't let you connect. It won't let us connect because there is one piece that is missing. Okay, so the piece that is missing is called Internet Gateway. So if this would have been a default VPC, then it would have been directly connected. But since we have created our VPC, we have also created subnets, and one of the subnet is public IP address, but there is no internet gateway available at the moment. So what I'm going to do is I'm going to add a network gateway to this. So we are not able to connect to this instance. So I'm going to close this. So we're not able to close to this one or the Windows one as well. So we won't be able to connect to both of them. So for that, we need to add the internet gateway. So in order to add the internet gateway, we need to go back to VPC. And within VPC, the option is right here, internet gateway. So when you go to internet gateway, so internet gateway, there is that default gateway available. So I'm going to just name this.
Adnan, why you are not able to connect console?
Because the internet gateway is not attached to our VPC.
But
can we create a new gateway?
Yes, I'm going to create a new gateway.
No, but last time.
Okay, got it.
But last time we were able to get in without internet gateway.
In AWS?
Yeah.
Yes. So okay. So let's understand that. Ajmal, your question is it's an important question. Yes. So by default, when we create a new EC2 instance, that all goes into the default VPC, default VPC, and with a default VPC, there is a default internet gateway. So that's why we are able to connect. But this time we created our own VPC, so we need to create our own internet gateway as well.
Okay.
Okay, so this is the default internet gateway where we normally connect to. So it says default VPC. It is connected to a default VPC. Now we are about to create our own internet gateway because this is our own custom VPC. So here, all you need to do, so remember guys, everything is going logical. Logical is first we create VPC, then we create subnet, and now we are creating internet gateway. So when we create internet gateway, we need to go here, create internet gateway, and I'm gonna name this so 360 cloud internet GW01. So this is our gateway, and the tag is there, and you can see there is nothing, there is no numbers, there is I mean just the name and the tag, and that's it. So once we do, behind this, it will create, AWS will create an internet gateway to this. So once I go into this here, I need to attach this internet gateway to a VPC now. So, excuse me, the main purpose of internet gateway is to open, is to connect your VPC to internet. So since we have created this gateway in real environment, it would have been, oh, I need an internet gateway. So you need to go into the market, buy a hardware internet gateway or a router that we know as exactly like a router that is sitting at your home from your ISP. So this internet gateway is equal to the router that is sitting at home. So we would need to buy a router, then bring it to the data center, connect, and there are so many things that you need to do. But here in the cloud, it's that easy. You just created an internet gateway, and they will just publish an internet gateway. All we need to do that this device now need to connect to our VPC. So if you don't connect it, internet gateway is there, but it won't work. So now I'm going to just go here, attach. In the attach, it will connect to VPC. So it's not showing us, why is it not showing us the default VPC? Because default VPC is already connected to its own gateway. So it's only showing us this one VPC here.
But we need to put it in a public subnet.
So public.
Not on
No,
a
right now
VPC.
we are in the VPC. After that, we have subnets.
Okay.
Yes. So here let's clear that confusion as well. So first of all, gateway is connected to VPC. Okay. So once the gateway is connected to VPC, the public or private is decided when we created the subnet. So we said when we created this subnet, when we created a private subnet, when we created these VMs, sorry, it is decided when we create these EC2 instances that we said that we don't need public IP address on a certain instance. So that instance is not going to use internet gateway where it doesn't have a public IP address. Right?
Okay.
So that's one place, and then we will configure the routing table as well. So we will have to configure the routing table. Now, when you connect, so it is attached to the VPC, and all we need to do now is, so we created a we created a internet gateway. We attached it to a VPC, and now attaching this. So once it is attached, I'm going to go back to internet gateways. So now we have two internet gateway. One internet gateway is the default one. This is the other one. It is connected to our cloud attached. We have our subnets that are here. So we have two subnets. So this is our public subnet, and this is our private subnet. If I select to public subnet, right here under this, I can see that there is details for this public subnet. In the public subnet, it is connected to this VPC. It has a private IP address. It is on this availability zones. There are these number of IP addresses available. Now, since two IP addresses are used, remember for interview purposes, that from the subnet, first 5 IP addresses are unusable. So rest is 251. And since we used two instances, we installed two instances in this subnet. This is why 249 IP addresses are left. So 2 of the IP addresses are used within this. Now there is a routing. Sorry.
sorry to interrupt you. Can we also assign the
I cannot hear you if you're
Can
asking a
you hear
question.
me now?
Yes, I can hear
Hello?
you now.
So I was wondering, can we actually also, arrange the range like it uses from 15 onwards, just not the 5?
No, no. So so you're saying that can we increase the range of the reserved IP addresses?
Yes.
If we reserve the range of the reserved IP addresses, then definitely the range to use will be smaller. I mean, I'm just trying to understand the question. Maybe I'm not able to answer properly.
Yeah,
But why do you
that's
think
what
that
it was.
reserve IP addresses needs to be increased? Yeah.
So like just for our own private computers that might need to access it, right? So wouldn't we give them like a static IP, like some specific instances or something like
Oh,
that? Like,
okay, okay. I get it. So yes. So in here in the cloud, so guys, the question is, can we have more IP addresses reserved from this range so that we can use static IP addresses on these VPC on these EC2 instances? So that happens in from our corporate network side. But by default in here in AWS cloud, it will automatically provide us IP addresses. So these
okay.
IP addresses are automatically assigned to all these machines. Now, in order to reserve them, these IP addresses will be reserved inside the EC2 instance. So if we don't worry about them at the
Oh,
moment.
okay, makes
Okay.
sense.
Okay. So in here now that we have connected, we have internet. Now let's try this. Now let's try to connect. So I'm going to go to one of the EC2 instance. And since I need to jump back from both of them, I'm going to open that in another tab.
Brother
For
Adnan,
EC
did you modify the routing table?
No, I didn't. Everything is the same. All we did, created VCP, subnets, and internet gateway, and attached to VPC. That's it.
Yeah, and after that you have to modify the routing table also, right?
So before that, let's see if we are able to connect. If we are not able to connect, then we'll modify the routing table. Okay, so I'm just going step by step so that everything is understandable. So let's see that if it works or not. So we did essentially 4 steps only. Okay, so in here, I'm going to go to right here within the instance. So I'm going to select, so we all understand that we won't be able to connect to this private instance. The private instance won't be able to connect, but will connect to the public instance. So I'm going to select public instance, connect, and okay, so that's the Windows instance. I can try first the Linux instance. And in here, let's try to connect. It's not connecting. I think we do need to, if I remember correctly, we do need to provide a route to routing table. So let me first fix it, then I'll explain this. So I'm going, okay, so I had that open on the other VPC. In the VPC, I will go to the routing table, and within the routing table of, so this is a routing table. So I have 2 routing tables here. This is the default VPC, and this is the one that is used for our VPC 360 cloud. So this is the one. And how do I know, guys? It's right here written. This is the default one. This is the one used by the 360 cloud. So let me go. So right here, and on this routing table, there is only one route available at this point, which is private route, which means that all the machines in this route will be able to connect. I'm going to add another route, and that route will be to that all the traffic, and I'm going to explain that. Just let me fix that. So it's saying that from in this routing table, all the traffic that needs to go out can go out through internet gateway. So I'm going to connect to internet gateway, this is my internet gateway, and save route. So in the routing table, I've added just one route for our internet gateway, that all the traffic from this routing table can go out to the internet gateway. Now let me quickly try that instance. And in here, I'll connect to this and connect to this instance. So this time it is connected. Okay. So now let me show you what we did to fix this. So I am connected to the instance. So I will be able to connect from this instance. And if I try the same thing on my private instance, I won't be able to connect. So if I try to access the private instance and go here, I won't be able to connect. So it's saying connection problem. I mean, connection problem directly, that it's just saying that it doesn't have a public IP address. So it directly gave that error message. So the only way to connect to that instance will be from the public instance, that I connect from this instance and then go inside this instance. Now, before that, let me quickly explain that what we did in the VPC. So in the VPC, in order to complete the connection, all we did was right here. So all we did is that, so first of all, we created VPC, then we created a subnet, and then inside the subnet we placed some VMs, and then we created the internet gateway, and internet gateway was connected to VPC. So this is connected, but then we need to change the routing table. The routing table was before, there is only one line in routing table that all these subnets can talk to each other. So that is one line in the routing table. The second routing that we needed to add was that in this routing table, all the traffic from both the subnets. So when we say 0.0.0/0 means that all of the traffic can go out to IGW. So this is all we did in the routing table. So we said that all the traffic, and before adding this, we were not able to go out on the internet, and from IGW it goes out on the internet. So in this lab, we did, I think, these 5 steps here: create VPC, create subnet, and then create EC2 instances. And then we created IGW, which is internet gateway. And then we changed the route. And then we added this to, fifth one was add this to VPC. And then sixth is add the route, and seventh is test the connection. So that's what we did.
Now, one more thing left, brother. We need to
Yes.
connect to that machine on the private network from the public one.
Yes, yes. So that's what I'm about to show you. So the 4 steps we did: VPC, subnet, routing table, and internet gateway. Now I am about to connect to.
Can you just show us quickly to how you add the route?
Okay, I will show that. So in order to add a route, you need to know which internet gateway you're working on. So don't change the route on default VPC, change the route on your own VPC. But your question might be, we never created this. Guys, this is automatically created when you create your VPC. So the first time when we create a VPC, routing table is automatically created. So all we did, we went into this routing table, and in the routing table, we went to routes here, and within the route, I went to edit, and in edit, I just added this one more route, just like this. I said 000. So all the traffic, I can say maybe traffic from one IP or 2 IP, but I'm saying all the traffic can be sent to, so there are many other, you can send it to many other places, but here I need to select internet gateway. So I'm sending it to the internet gateway. And when you select the internet gateway service, it will show you your internet gateway, and you can just save the route.
Thank you.
Okay. And I will make a video on this as well, guys. You have to do that 1, 2, or 3 times so that we can understand. And also please remember that not just doing the video is not enough. You need to draw it on a paper and make sure that you understand the complete architecture.
You know, brother
So,
Adnan, when
Adnan
you
bhai, oh, go ahead.
when you posted the video for Bashan, that time I started from scratch, like creating my own virtual private net, virtual private cloud, and I struggled for 3 days, like connecting. But when I was able to figure out and did it.
Excellent, 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 excellent. That's the way to go. So now that, I mean, when I was creating that routing table, it was already in your mind, and I mean, so that's what happens when you're stuck on something and you try to fix it. It goes into your permanent, I mean, long-term memory.
Yeah.
Good, excellent. So
So
Ashish, you have a
Adnan bhai,
question? Yes.
yes. So for the public Linux machine, I did not give the HTTPS thing. Does it really matter? Because the machine actually connect right now and it's working completely fine.
Yes. So in order to access the website, you need to provide HTTP. If you haven't provided
Oh,
that,
right.
all you need to do is go to EC2 instance, go to EC2 instance and go to the security group and just add the route. So all you need to do is go right here within EC2, within security group, and your public security group right here. Go to the inbound port and add this right here. Okay. So guys, the last thing for today that we need to do is to connect from public instance to a private instance. And that is basically all we need to do now so I'm going to go back here in EC2 instance, and within EC2 instance, I'll be connecting to public instance, and from the public instance, I will be connecting to the other. So I can connect either from Windows instance or I can connect to Linux instance. So in the lab, I will be showing you both of the instances here. So for now, I'm just connecting to Linux. So first of all, connect. And here we know that this is the command that we need to connect to the private instance. So for now,
So the
I'm just
bootstrap didn't really work. I just connected to the machine, but other than that, it worked perfectly
bootstrap is not working.
fine. No.
Yeah, sometime it doesn't. Sometime it
Yeah.
doesn't work.
Well, I mean, I manually ran it. Everything is working fine.
Yes. So in order to connect to this machine, we have few ways to connect. I can either connect right from here. This is the easiest way to do it. But you should know how to connect through PuTTY, and you should also know how to connect to CLI as well. So last time I connected from EC2 instance. This time I'm going to connect through my CLI. So in CLI, all you need to do is make sure that you have this command, and the command is right here. You don't need to remember the command, and this is right on the connect. So you select this the machine, then click connect, and just copy this command. And all you need to do, open your CMD command prompt, and within the command prompt, if you have already installed AWS CLI, you can directly run this command right here. So if you run this command, it is now asking do you want to, so I'll confirm that I'm about to use this, and it is connecting. So it's connected now. So now the only thing that you need to make sure is that this key is present on the same share. So this share, that shared, I have C users, my folder, a header folder. So in this folder, you have this key available. Remember that this key was downloaded on your downloaded section. So all I did, copy that key from there to in this section, then this command will run. Let's say if you don't have the key in this, and I'm going to exit. So I'm going to exit from this. Let's say if you don't have the key in this folder, then you will get a error like this. So it will say that identified file is not accessible, meaning the key was not here. So the only thing you need to make sure the key is copied here first, and then you can run this command. So I'm going to run this command, and I'm connected. Now I am connected to this instance. So here I'm connected to this instance. Now I need to connect to my other instance, which is this one, which is this instance. Now here, there are few steps involved because this is a Linux machine. People who work on Linux, they will be able to, I mean, it's easier for them. but if you follow the video step by step, you will be able to do that on your own as well. So all I need to do is to connect to this. But first of all, I need to know what is the IP address of this. So here, the IP address of this private IP address will be right here somewhere, or it's right here. This is the private IP address. So here, all I need to do, select the private machine and connect, and I will copy this complete command. I will copy this complete command. So first of all, what I need, the only challenge here, yes, please go ahead. Okay, so the challenge you will be facing here, guys, is that that you, first of all, the key should be in the same, the key should be on that server. On that server, the key should be there, and you need to run this command where it says your key must not be publicly viewable, which is you need to run this command to restrict the key, and then you need to connect to this IP address. So the tricky part here, let's try to understand. I know it's late and everybody's tired, but let's quickly understand this tricky part. The tricky part is that we are connecting to server number 1, which is public. Now I need to connect to the other server that is in this within the same within the other subnet. So I will be able to connect, but the tricky part is that how would I bring the key to that server? So the problem is that I'm on this VM and I need to connect to this VM. Yes, the routes are available, but how do you get the private key of this server on this server? Then you will be only able to connect. So in order to bring that key here, in order to bring that key, we need to copy that key in this server and then save the key and then run the command. So I'm going to do this now. I think it is difficult for, if I run this command right now here, where am I connecting? I am connecting to this server, which is a private server 203, and I'm using the key. The key is not here on the server, so this will definitely error out. So here, if I say yes, so it's saying that this server is accessible, but the key is not here. Permission denied. You don't have the key. So where is the key? The key is basically on my machine that we downloaded. Remember that we always download a key, and the key is, so key is right here. See, so the key is one of this. So the key is this one, and you can just this is the same key that we downloaded. So the key that we have, I can open it with Notepad. So first of all, I need to open it with Notepad, and the key looks like this. So this is the complete key. This is the key that they say that you cannot, basically nobody can decrypt this key, not even hackers and all that. Probably maybe few people can decrypt, but this is the main key where everything is connected to. So we don't need to understand this key. All we need to do is to copy this. I'm going to copy this here. And I just said, I just used Control C to copy this. Now I need to create a file in this instance, which is 101, so that I can connect to 203. So this exercise, what I'm doing is I'm trying to connect from this machine to this machine. I know that this might be few more steps, but just keep on looking for maybe 5 minutes more, guys. This will be clear. So in here, first of all, I need to have that key in a special folder. So for that folder, first of all, I need to have sudo access, number 1. So I had a sudo access, and then I need to go back to, I need to basically go to this folder. Okay, actually, I can make the key right here. So I don't need to go to any other folder. I can use, so Nano is basically an editor in this. So I'm going to use the name Nano. And so I'm just naming this key. So the name of the key, I'm just using the same name because this will be much easier because I have the command ready. You can have any name. So Nano is the editor. Once I do this, what it does, it will open it in the editor. So this is the editor, and all I need to do is
Control V.
Control V, yes. So it is copying, but at some time this editor is totally a text-based editor. Maybe probably I'll copy that again one more time. So copy, and let me see if my copy is working. Yes, it is working. So I'm not gonna save this because this is the main key. And in here, I'll just paste it. Okay, so let me see one more time. Here are all the commands. All I did was Control G is right here to see the help, and copy operation is right here. It's saying, so mark the task and copy current line, paste. I need to paste it actually. So the paste is, it is Control V. I don't know why it's not working.
Right click and then paste.
No, this is completely a text editor. So where is the next file?
Or use a VI.
Which one? Use VI editor. Yes, VI can be used as well. So from here, I'm just gonna close. So save. So it's out now. So, and why is it a smaller font? I'm gonna use a larger font here. And okay. So clear. And I think we can use the VI editor, and within the VI editor,
Control V. Oh, insert I.
yes, I'm actually, I just wanted to come with a username. And since this is, it won't be able to save because, okay, hold on.
Okay.
Okay, so just since the time is running out, what I'm gonna do is I'm gonna try again with EC2 instance connected right here. So this is, I'm connected here, and okay. I think
Insert.
insert.
I believe Control I or something. No. Just I, and then paste. Insert I. Yeah.
Okay, just a second here. So I'm just looking at the. Okay, so here. Okay, so from the clipboard, it's saying on the keyboard shortcut Control O. Tried, yes. I tried Control V many times. It works fine. So you could try Control Shift V, Control Insert to paste from the clipboard. Okay, so let's try this.
Shift insert. Yeah. On VI shift insert.
Hmm?
Insert. Okay, paste here, paste here.
Oh. So copy and Control Shift V doesn't work. Okay, so guys, I'll do that, and I will create a video for this. I mean, the main purpose of the networking was to create the VPC and subnets and connect them all together. This step I will add it to the video, and then you can follow me from there. So, any other questions in this regard?
One question: if I miss the public IP address, how do I put it back public IP in an instance?
How do you put a public IP back on the instance? You need to get a elastic IP address and then associate that elastic IP address to an instance. So that's where we can get the public IP. If you don't have a public IP address.
Yeah. Okay.
Excuse me. So we have 4 instances, and 4 instances. We could have done it on Windows as well. So guys, everyone, please I will post the videos as well. So if you have any questions at all, you can just post your question in the group. And how many of you are preparing for the exam? Anyone is planning to go for the AWS exam?
Can we trust these dumps which we have been provided?
I think there is no other choice. Is there any other choice?
Adnan bhai, it has only a 50 question. Is it a valid?
Oh, really? I haven't seen them. It's not 50.
I see that. It's only a 50 question, 55
No,
question.
that is that's the Azure one. That's the 55 questions. So the AWS have more questions.
AWS is 272. Okay, sorry.
Yes, 272 questions. So I think
Come on,
Shakil,
Ajmal.
yes. Yes, go ahead.
272.
Yeah, actually, brother Adnan, I tried to do it, but it's so confusing. Every answer seems to be correct.
Yeah, that's true. The thing is, it has a value. So all the jobs require certified people. I mean, especially cloud. So it has a value. It's worth it.
So
The problem is,
I would like to check if there is a newer version available for the dumps, because these dumps are like 3 weeks old, I believe.
Okay, so
No,
maybe paste
I
a
think
question in WhatsApp group for Amin bhai. I'll ask him to update. I think that's the latest one. Yes, Shakil, go ahead.
No, yeah, these dumps actually, these dumps are also available somewhere on the site, and I see they keep changing the dates also. The latest is the same questions I saw for 6th November.
Right. I mean, they don't much changed. So these dumps are around 80% correct. So there is that 20% where you need to, try your best.
Any voucher available?
Yeah, for
Yeah,
AWS,
brother, voucher.
I don't think there is a voucher available for AWS. There are some times for Microsoft, but not for AWS.
Right. And how much is that? The cost?
I think it's 200.
150 US
Okay.
dollars, I believe.
Yeah, 200 Canadian.
Okay.
So somebody's gonna have to be the guinea pig to go in and do it. And that's the only way we're gonna find out
No,
that
there
if
is
it's valid.
That,
there is one person
could
that
be
went
the
through
key.
this. So there is
That
one
could be
person already went through using this exam. So it's fine. It's 80% good.
Shakil, show the courage.
Sorry, what?
Show the courage.
Sorry, what was that?
the guinea
Ajmal-
pig has
Shakil
to
will
be
do it.
somebody like who's
Ajmal.
going to be telling.
Ajmal, Ajmal.
I will be the second one.
Somebody who can memorize 270 questions.
I think Ajmal Bhai is the best one.
Ajmal is the
No,
best one.
that's
I think
fine.
he
The
memorized
thing is-
900 questions. Ajmal went through so many certification, right, Ajmal?
No, but the thing is, the dump should be valid. Even 900 is no problem.
Yeah, that's true. That
Yeah,
is true.
so Admiral, by then 270 is nothing for you.
Oh, yeah, for sure.
We don't know this.
So when can
This
we expect you to come back and say I passed?
yeah, after Shakil.
Why?
Brother Adnan, honestly, I was trying to do it, but it takes so much time that I was missing my labs. That's why I think maybe I should finish the labs first, then I should try it.
I think you need to do both at the same time and
But
do
it is
that
taking
maybe
too much time.
within next 3 weeks, so that you already
Ashish,
went through
Ashish.
Azure, right?
Yeah, I
When
went
we
through
starting
Azure.
the
It was fine.
GCP?
So is the Azure one valid? And there's only 50 questions on it?
No, Azure one is, I think, yeah, it is valid. 104 questions.
103.
103, yeah.
And it's valid. Many people went
Yeah.
through in the last week. Yes.
Okay, is that on the drive already or no?
Yes, it is there.
Okay.
Seems
So
like Ashish will be going for it.
yeah, Ashish is going for this. Human, I think Human is sitting here. He went for Azure as well, and he got it.
Sorry, who
Only
is
thing,
our
going?
guys, I would recommend is just try to get the VCE player. That's pretty much the best thing, right? Like you just keep on doing the questions, up until you pretty much get all of them green, and then you're pretty much ready
Ashish,
for
I
your
think,
exam.
Ashish, that is an additional expenses. We did Azure without that player, man. We did it.
And what we did on the other group was we just shared the expense basically, right? Because you get two computers, so just two of you pitch on like one of them, and then you have Amin by shared the coupon, right? I shared it again
Yeah.
on the group, so it's like another 40% off. So it's
Yeah,
an
but
investment, man.
honestly,
Pretty much,
Okay.
right? That's it.
That's
in
good.
our group, everybody passed Azure. I think most of the people without that VC player.
Hey, that's a good thing, man. But if you want to make it a game, and
Okay,
just have to
that's
treat it
excellent.
well.
Majbin passed Azure as well. Excellent. So
Yeah.
Human,
And the,
Atif, I think most of the guys.
and the good thing is a $15 voucher.
No, I paid full actually. It didn't work for me.
Oh, it worked for me.
So
$15.
apparently there is a place where we can actually go purchase all the vouchers. I think so. It was on Pearson View. I don't know if you guys want to go check it out, and if you guys want to, I think so. They sell it in a group, like a big chunk of it. So if you guys want to go together and buy some, we could do that as well.
Okay, brother Adnan, what we are doing tomorrow? Because actually tomorrow I may be not available. I'll be watching video.
Okay. Yeah, tomorrow we're doing the security, and plus we will be adding some, so VPC as well. We'll review VPC, but mostly we'll be doing Active Directory and security.
So maybe I will need the recording immediately.
Yeah,
because
yeah,
tomorrow
for sure. Okay.
Okay, thank you, sir.
Okay,
Thank you.
everyone, this is all for tonight.
So anybody have the VCE player right now that wants to share the cost? with me.
Use the PDF. Use the PDF.
Okay.
Yeah, you can use the PDF, or if you
PDF
Didn't
is
you have the
better.
older version of the VCE player you said?
Yeah.
Why don't
Most
you
of the questions are repeated.
But
So
it's like 7 years old, so I don't know.
yeah, it won't
that
work.
doesn't matter. It doesn't really matter. All it matters is that you have to convert the PDF into it, right? That's it. So just try to take the designer and convert it into a rich text format
Yeah.
from PDF, and then it should be working. I mean, if your player is working, it should be completely fine.
no,
Okay.
the
I'm gonna
it
call
is
you
now
later if it's okay.
Sure, no problem.
Okay. Jazakallah.
Adnan bhai,
Yes.
what is EMV? There's a recruiter asking me EMV. What is that?
EMV
He
in
said you have experience with EMV.
You know,
EMV.
recruiter keep asking these stupid things, you know.
Recruiter doesn't know, maybe.
Yeah, they do, because they look at it on their job description and from their EMV.
And you know, they don't even know what is that. You say, "Oh yeah, I work it a lot of time. It's really good thing. It's the future." They say, "Okay, yeah,
yeah,
I'll
that's
get you
the
an
that's
interview."
the reply.
Okay.
Then leave it. Okay.
Right, right.
Okay.
Okay,
Thank you.
guys, thank you so much for today's session, and we'll see you tomorrow, inshallah.
Thank you, Adnan bhai. Allah
Okay,
Hafiz.
thank you.
Have a good
Thank
night.
you. Allah
Bye-bye.
Hafiz.